0 and liftoff of the Delta rocket with Mars Pathfinder.
It rocketed 499 million kilometers, traveling over 400 kilometers per hour.
Spacecraft is go. Roger.
Now the Pathfinder spacecraft lands on Mars.
I'm John Holloman. Join John Zarella and me for complete live reports and witness the first ever television images beamed from the surface of the Red Planet.
July 4th on CNN International.
1996 begann mit dem Start der Raumsonde Global Surveyor eine neue Ära in der Erkundung des Mars. Die Reise der 1060 Kilogramm schweren Sonde wird insgesamt 10 Monate dauern.
Mars Global Surveyor arrives.
Mars Global Surveyor wird in eine Umlaufbahn um den Mars einschwenken und durch die Marsatmosphäre fliegen, bis die Umlaufbahn immer kleiner und kreisförmiger wird. Die Sonde wird die Marsoberfläche 2 Jahre lang abtasten und mit dem Laser Höhenmessungen durchführen, damit wir wissen, wie hoch die Berge und wie tief die Canyons sind und aus welchem Material der Mars besteht. Die Messungen und Bilder sollen außerdem Aufschluss über mögliche Landeplätze für spätere Missionen geben.
Neben dem Global Surveyor ist auch eine zweite Sonde unterwegs, der Mars Pathfinder. Nach dem Eintritt in die Atmosphäre öffnet sich der Fallschirm, dann fällt die Sonde auf den Boden und springt wie ein riesiger Ball 20 bis 30 Meter hoch. Airbags an allen Seiten sollen verhindern, dass das Gerät beschädigt wird. Nach der Landung werden die Airbags entlüftet und das Landegerät freigegeben. Das Vehikel wiegt 300 Kilogramm. Und damit weniger als die Hälfte als die Viking-Sonden, die die NASA erstmals vor mehr als 20 Jahren zum Mars geschickt hatte. Im Inneren des Pathfinder befinden sich eine Instrumentenplattform und ein kleiner Mikrorover. Die notwendige Energie für die Operation Pathfinder liefert die Sonne. Solarzellen an den Wänden der Kapsel machen es möglich. Der Mikrorover ist das erste autonome Vehikel, das je auf einem Planeten abgesetzt wurde. Es soll Bilder von der Marsoberfläche liefern, Daten über chemische Zusammensetzung des Bodens zur Erde funken und vor allem seine technische Tauglichkeit als Marsmobil unter Beweis stellen. Mindestens 30 Marstage, so rechnen die Wissenschaftler, wird der Rover arbeiten können. Optimistische Schätzungen gehen von bis zu 1 Jahr Lebensdauer aus.
Well, sit back as we blast off on the latest journey in our quest to understand our universe.
Start one ignition, 0 and liftoff of the Delta.
In December, NASA launched Pathfinder, a mission to Mars. Pathfinder is scheduled to arrive on the Red Planet on the 4th of July. It's carrying a 22-pound mechanical geologist of sorts, Sojourner, a high-tech robot designed to explore the Martian surface. Sojourner will be the first earthly visitor to Mars in more than 20 years. It'll roam the surface, closely inspecting soil and rocks. The Pathfinder mission has gained urgency since the recent discovery of Mars meteorites with possible evidence of primitive life. Well, the mission now underway is being called a Pathfinder to our future, and the next generation of space robots and rovers is already waiting in the wings. CNN's Kathy Nellis reports on an international effort to develop mobile Martian machines.
Robots and rovers from around the world hit the sand in Santa Monica, California. Someday soon, these machines could roam the surface of Mars.
This is a research rover being designed for future missions.
Scientists from around the globe held a high-tech show and tell, the International Conference on Mobile Planetary Robots and the Rover Roundup. The event provides a glimpse into the future of planetary exploration with a look at some next-generation advances. Take Rocky 7 from NASA's Jet Propulsion Laboratory, or JPL. It's similar to Sojourner, the robot on its way to Mars, but Rocky has several new features, like this mast, which allows it to take panoramic pictures. It also has a digging arm to collect soil.
And that's very important for future missions, because for future missions, the idea is to actually bring samples back.
Teams from all over the world came with their rovers. This giant is from Russia. This is a Japanese model. And here's a German robot. The complex machines come in all shapes and sizes.
Is size important?
Well, size is important. A small rover can cost less and cost a lot less to send to Mars. A big rover can carry more instruments,
JPL's Nano rover is the smallest of the lot. Its tiny camera can focus on rocks with microscopic accuracy. Scientists are eager to learn what the history of Earth's nearest planetary neighbor can tell us about our own future.
Maybe a life existed on Mars many billions years ago. Climate was more calm, warmer, water existed.
I think Mars is our closest neighbor, so except the Moon, so it's quite obvious that it's a good target to go there.
Mars exploration responds to that basic human outlook on what is our relationship to the universe? Where did we come from? Are we alone in the universe? All the questions that humans have been wondering about through religion, through mythology, through folklore, and now for the first time through science and technology. Mars is the only other planet we know of anywhere besides Earth that could have had life take hold there.
Scientists say knowing more about Mars could help us avoid some fatal mistakes.
It's possible that humans could change the surface of the Earth to be either to lose the atmosphere like Mars did, or have a runaway greenhouse effect like Venus did, and thereby have the Earth be uninhabitable.
While the rovers look very different, they share a key feature: mobility. They must move around to explore the surface.
It's going to be virtually impossible to find evidence of life on Mars unless you can move around. And even then, it'll probably be difficult.
This German model is tethered to a command module, which provides power and communication links. Even on Mars, wires will connect it to the unmanned control panel. Researchers say this reduces the amount of electronics needed inside the rover, allowing more room for samples. Other rovers are wireless, and some operate autonomously, responding to commands from Earth, then actually thinking out the best route to their destination. It takes 20 minutes for a signal to travel from Earth to Mars. And sometimes there are glitches. Since humans won't be around to provide an instant fix on Mars, many robots have built-in safeguards. Rocky 7 got its name from its rocker wheels.
If you go to this rover and you lift one of the legs, you see that the other ones remain on the ground. This has a special mechanism that allows the rover to go over rocks without tipping over.
The Nano rover can actually flip over to right itself, or raise its belly to go over rocks or obstacles.
What's the biggest difficulty when you're designing something for planetary exploration?
Well, I think you end up having to design something for a series of conditions you can't really well anticipate. I mean, we haven't been to Mars for 20 years. The place we're going to is not a place where we've been to before.
With so many uncertainties, why not send astronauts instead of machines?
Because it's very expensive to send people places. So you want to send robots first because they're a lot cheaper and they can provide kind of a virtual presence for people at the planets.
And technology keeps getting better.
Technology breakthroughs are enabling us to do so much more for so much less money.
Another way to cut costs: international collaboration as scientists share research.
It means that each country need to spend less money because money limited in each country.
Space, its ability to fascinate and to challenge our imagination, seems renewed with each generation. In Santa Monica, California, Kathy Nellis, CNN Future Watch.
It was one of the biggest science stories of 1996, the possibility that primitive life once existed on Mars. The evidence was streaks of mineral in Martian rocks, mineral that might have been left by bacteria. Now, living bacteria from deep below the Earth's surface could help scientists determine whether the Martian rocks really offer proof of life. Dick Wilson explains.
The headline screamed "Life on Mars." The story held the public's attention for a week last August. Scientists weren't talking about living alien beings, but possible fossil evidence of tiny bacteria that might have lived on Mars billions of years ago.
What I think you've seen here is a very compelling case for the possibility of life on early Mars. And it's been built on several lines of evidence involving the organic chemistry of this sample, mineralogical evidence, and even structural evidence of this sample.
Among the traces of chemicals analyzed was iron material called magnetite.
The rims are composed of very fine-grained minerals. One of the minerals is called magnetite, and it's composed only of iron and oxygen. These shapes are very similar to magnetite that's produced from bacteria on the Earth.
Researchers at Oak Ridge National Lab have found living bacteria here on Earth that produce similar magnetic material on the surface of their cells. They were discovered in rock samples from deep oil exploration drills in Virginia and in Colorado. This discovery could lead to a clearer idea of just what microbes might have lived below the Martian surface.
It's a close-up of the bacteria, and you can actually see the little magnets being formed right at the cell membrane surface. And these are the best pictures I've seen that actually show very, very small nanometer-sized particulates right on the membrane surface.
Microbiologist Tommy Phelps and his team grow the bacteria in petri dishes in the laboratory. Phelps says the bacteria thrive on high temperatures without oxygen, and they feed on glucose. Their waste products break down the iron compounds in the environment and produce magnetite. Phelps says this type of bacteria may have lived on Earth and other planets for millions of years. The magnetic material is clearly visible when an ordinary magnet is placed nearby. Scientists know that magnetite is also produced by chemical actions that don't involve living organisms.
And maybe we can use these organisms to see if there are differences between chemically produced magnetite at high temperature and pressure and magnetite produced biologically.
That information could help scientists prove or disprove the life on Mars claims. Here on Earth, Oak Ridge has some practical applications in mind for those exotic microbes. They can separate and condense some toxic materials and heavy metals from groundwater. They could be used to clean up radioactive contamination.
Possibly, organisms such as this could complement the precipitation and immobilization of uranium.
So it might make the cleanup more effective?
More effective, faster, cheaper, easier.
Two other potential uses, making magnetic fluids for brakes and lubricants for turbines. Dick Wilson, CNN, Oak Ridge, Tennessee.
Beispiel Mars Observer. Der Aufklärungssatellit startete am 25. September 1992 planmäßig. Nach 11 Monaten und 720 Millionen Kilometern Flug meldete sich die Sonde einfach ab. Verschollen im All. Beispiel Mars 96. Ein russisches Projekt. Start am 16. November letzten Jahres. Mit an Bord deutsche Technologie. Hochleistungskameras für 250 Millionen Mark entwickelt. Landung ein paar Tage später, aber nicht auf dem Mars, sondern im Pazifik. Die Gesamtbilanz: 18 von 28 Mars-Missionen missglückten. Das Wissen über den roten Planeten stützt sich daher in erster Linie auf die Daten der beiden erfolgreichen Viking-Missionen aus den 70er Jahren. Demnach präsentiert sich Mars als Frostkugel. Durchschnittstemperatur -60 Grad. Der Luftdruck der CO2-Atmosphäre beträgt 0,5% der irdischen. Sandstürme färben die Luft je nach Stärke orange bis rot. Die Farbe der Oberfläche rührt übrigens vom hohen Eisengehalt her. Der rote Planet ist im wörtlichen Sinne verrostet. Im Spätherbst 96 konnten Zuschauer in Florida wieder 2 Starts zum Mars beobachten. Die beiden Missionen sind momentan unterwegs. Mars Global Surveyor, ein Beobachtungssatellit. Er soll einen Teil des Mars Observer Programms nachholen. Falls alles klappt, wird die Sonde im September am Mars eintreffen, von der Marsatmosphäre abgebremst werden und in eine Umlaufbahn um den Planeten einschwenken. Hochauflösende Kameras sollen die Marsoberfläche fotografieren. Die Landung der zweiten Mars-Mission Pathfinder ist schon für den 4. Juli geplant. Das geringere Gewicht erlaubt eine höhere Reisegeschwindigkeit. Ein 28 cm hoher, solarbetriebener Mini-Rover wird tagsüber den Mars erkunden. Er sieht mit einem Laserstrahl Hindernisse und kann sie je nach Größe überwinden oder umfahren. Mit Hilfe eines in Deutschland entwickelten Spektrometers kann er die chemische Zusammensetzung des Marsbodens analysieren. Diese unbemannten Missionen sind für die NASA nur Vorspiel für Menschen auf dem Mars. Doch warum müssen wir da unbedingt hin?
Menschen haben immer durch die Evolution Dinge unternommen, die die vorherige Generation noch gar nicht eingesehen hat. Der Mensch hat den Luftraum, die Ozeane, den Luftraum, auch Länder für sich erschlossen, obwohl ursprünglich auch Menschen sagten, was soll's, was wollen wir in der Luft, wenn der liebe Gott uns Flügel gegeben hätte, dann könnten wir fliegen, aber warum sollen wir die selber bauen? Und so erschließen wir jetzt die 4. Domäne, das All, den Raum, genau eine Domäne wie Land, Wasser, Luft und nun das All. Und auch wieder gibt es Zweifler und Leute, die fragen, warum sollen wir? Aber es wird trotzdem gemacht werden und Evolution zwingt uns irgendwie, oder die Leute, die nach uns kommen, gegen alle Widerstände, gegen alle Neinsager, gegen alle Kritiker, doch irgendwie Wege zu finden, es durchzuführen. Die Geschichte zeigt das.
Und das ist die Idee des NASA-Chefplaners Jesko von Puttkammer. Eine ständig bemannte Raumstation dient als Startplatz für Flüge zum Mars. Diese Station könnte die geplante internationale Raumstation sein. Ihre Montage soll Ende dieses Jahres beginnen. Der Flug selbst? Rund 10 Monate in der Schwerelosigkeit oder länger, wenn umgekehrt werden muss. Das wird Probleme geben. Der menschliche Körper in der Schwerelosigkeit, schon heute Hauptforschungsobjekt auf den bemannten amerikanischen und russischen Missionen. Bedingt durch die Schwerelosigkeit verliert der Mensch Muskeln und Knochenmasse. Marsfahrer müssten bis zu 4 Stunden täglich trainieren, um vor allem den Muskelschwund zu bekämpfen. Und dann wieder die Gewöhnung an die Schwerkraft. Langzeitflieger von der russischen Station Mir müssen aus ihren Kapseln gehoben werden. Sie können tagelang nicht geradeaus laufen. Die Gewöhnung an die Schwerkraft des Mars nach der dortigen Landung wird nicht ganz so schlimm. Die Gravitation beträgt 40% der irdischen Schwerkraft. Doch auch nach der Landung bleibt das Leben der Marsfahrer beschwerlich. Dafür sorgt die Sonne. Die harte UV- und Teilchenstrahlung der Sonne wird durch die hauchdünne Marsatmosphäre kaum geschwächt. Selbst in den kühnsten Plänen der NASA steht in der Marsstadt auch ein strahlungssicherer Sturmbunker. Zufluchtsort bei Sonneneruptionen, den härtesten Quellen ionisierender, todbringender Strahlung. Ein Leben in Schutzanzügen und Sturmbunkern? Sieht so das Los der Marsfahrer aus? Nur zu Beginn verspricht die NASA. Zukünftige Generationen sollen es viel bequemer haben.
Es ist also durchaus möglich, dass innerhalb von 10.000 Jahren eines Tages die Sonne nicht nur von einer Erde umkreist wird mit Menschen, sondern von 2 Erden.
Versprechen Sie also sozusagen auf dem Mars blühende Landschaften?
Ich verspreche es nicht, aber denkbar ist so etwas. Es ist nichts, was dem an sich paradox im Wege stehen würde. Es ist eine Sache der Chemie, der Biologie, der Pflanzenkunde. Der Mensch Tut es ja hier auf der Erde auch. Versucht ja auch, wenn Sie mal ansehen, was die Israelis aus ihrem dürren Land gemacht haben, wo kein Grashalm jemals gewachsen ist. Heute schlagen sie sich um die Häuser und um die Siedlungen. Menschen haben wirklich aus dem Nichts etwas geschaffen. Und so werden sie auch aus dem Marsboden eines Tages eine fruchtbare Umgebung schaffen können.
Eine Marsstation ohne Sturmbunker und UV-Schutz. Stattdessen mit Grünflächen. Menschen, die sich ohne Raumanzüge im Freien aufhalten. Eben wie auf der Erde. Blau-Grün-Algen sollen dem Mars eine Sauerstoffatmosphäre verpassen. Eine langfristige, aber durchaus ernst gemeinte Idee der NASA. Der Mars soll ergrünen.
Warum sollen nicht zukünftige Generationen keine unüberwindlichen Schwierigkeiten mehr drin sehen, wie wir sie drin sehen? Allein der Flug dorthin und die erste Fußfassung für die ersten Pioniere, von denen sicherlich viele zugrunde gehen werden, so wie sie auch bei der Besiedlung des nordamerikanischen Kontinents zugrunde gegangen sind. Das hat niemanden aufgehalten, eines Tages Chicago zu bauen.
Das Endziel des NASA-Mars-Projekts? Der rote Planet als zweite Erde. Aber wie gesagt, innerhalb der nächsten 10.000 Jahre. Chicago wird also noch ein Weilchen einzigartig bleiben.
NASA's Hubble telescope has focused its attention on the planet Mars. New pictures from Hubble offer several views of the red planet, including one that shows the planet during a Martian summer. Other pictures show Mars' polar ice cap shrinking and expanding as the seasons change. The newest images of Mars show it is colder and cloudier than scientists first thought. Scientists will get a closer look when the Mars Pathfinder probe lands on the surface of the planet on July the 4th.
Space agency NASA has released spectacular new images from the Hubble Space Telescope. The pictures provide what astronomers are calling the best, clearest views ever of the planet Mars. And those views are challenging some old ideas about our neighboring planet. CNN's Kaylin Thomas Samuel has more.
Hubble Space Telescope images of the planet Mars have astronomers rethinking their ideas about weather on the red planet. When the Viking landers sent back the first photos of Mars in the late 1970s, the planet appeared to be dry and dusty. Now scientists say new data indicates Mars has a colder, cloudier season too.
There really are two distinct climates of Mars. There's a climate of Mars when Mars is nearest to the sun, and there's a climate of Mars when Mars is furthest from the sun. The Viking and 1977 mission Viking and 72 mission Mariner 9 to Mars saw the dusty climate of Mars when Mars was nearest to the sun.
When the Pathfinder probe lands on Mars and deploys a small rover on July 4th, scientists expect to see a very different Mars than they've seen before.
When the Pathfinder lands in July, if these clouds remain, and they may or may not, because this is very chaotic switching between these two climates, what we should see is actually a very, very darkish, perhaps slightly bluish sky with brilliant white clouds against the sky.
Scientists also say Hubble has provided them with new pictures of Mars's polar ice caps, which shrink considerably when the planet is closest to the sun. And Hubble is helping astronomers better understand the changing appearance of surface features on the planet. Light reddish areas are covered in a fine, light-colored dust, while darker areas are bare rock. As the dust shifts with the wind, rocky areas are alternately exposed or covered. Scientists say the new findings about Martian climate and weather make Mars a more exciting planet to study.
A sky in the dust storm period is something like a very smoggy Los Angeles sky, perhaps beautiful in its own way, but I would say that the clouds and the clouds in the very dark bluish sky, I think, make it much more Earth-like, at least emotionally, and I think that makes it a more appealing planet, actually.
Over the next year, astronomers say Hubble, Pathfinder, and another probe called the Mars Global Surveyor, which will orbit and map Mars, should greatly increase our understanding of the planet next door. Kaylin Thomas Samuel, CNN reporting.
Has there ever been life on Mars? Last summer, NASA scientists said they had evidence there was. But a new study out this week contradicts that claim. The center of the controversy is a Martian meteorite found in Antarctica. The rock includes tiny grains of a substance called carbonate. The NASA researchers said last year that the carbonate might have been left by tiny living creatures long ago. But in this week's Nature magazine, scientists at the University of Hawaii say the material was formed by the impact that knocked the meteorite off Mars, sending it into space. They base their conclusions on electron microscope pictures of the meteorite. NASA says the Hawaiian findings don't disprove the possibility of life on Mars.
Besuch von der Erde. Dann erreicht nämlich die NASA-Sonde Pathfinder den rund 400 Millionen Kilometer entfernten Planeten und setzt dort das Marsmobil Sojourner aus. Aber schon jetzt hat dieses futuristische Gefährt Konkurrenz auf der Erde. In Chile testet die US-Raumfahrtbehörde einen neuen Roboter für die nächste Mission.
Auf dem roten Planeten soll das neue Mobil die Schluchten der Marsgebirge hinabklettern und auf die Berge des Himmelskörpers steigen. Um diese außerirdische Mission auf der steinigen Marsoberfläche zu erfüllen, probieren die Forscher ihr Gefährt Normet, zu Deutsch Nomade, in der chilenischen Wüste aus. Etwas behäbig erklimmt er kleine Hügel. 200 Kilometer schafft der Nomade in 45 Tagen. Aber dafür beobachtet er ganz genau. Seinem Rundumblick bleibt nichts verborgen. Auch die weit entfernten Gegenden des Mars soll er ausspionieren. Marsmobil Sojourner, übersetzt der Besucher, kann nur in der Nähe seines Landeplatzes Gesteinsproben analysieren und Fotos machen. Der Vorteil des neuen Roboters ist dagegen sein sehr viel größerer Radius. Wenn in 10 oder 20 Jahren Menschen auf den Mars geschickt werden, müssen wir die Umgebung ganz genau kennen und wissen, was uns erwartet. Neueste Erkenntnisse über den Planeten erwartet die NASA bereits am 4. Juli. Denn nur wenige Stunden nach seiner Landung wird Marsmobil Sojourner erste Daten an die Erde senden.
For the past 6 months, a relatively small, inexpensive spacecraft has been zipping along through the solar system. It's already traveled more than 300 million miles. And on Friday, if all goes well, it will become the first spacecraft to land on Mars in 20 years. John Zarella reports.
This pint-sized robotic rover departed planet Earth 6 months ago. A few days from now, on July 4th, the rover, named Sojourner, and no bigger than a child's radio-controlled car, is expected to take a drive on the surface of Mars.
3, 2, main engine start, 1, 0, and liftoff of the Delta rocket with Mars Pathfinder.
Since its December 4th liftoff, the Pathfinder spacecraft, with Sojourner neatly tucked inside, has been traveling more than 25,000 miles per hour on a 310 million mile ride to Mars.
There's a lot of people that would have given you good odds that we wouldn't have made it this far.
If Pathfinder makes it the rest of the way, it will be the first Mars landing since Viking in 1976. But the hardest part is yet to come.
That entry, descent, and landing part of that 5 minutes is something we've never done before, and that's all new.
A few seconds before landing, airbags will deploy to cushion the impact. When the spacecraft hits, it will bounce as high as a 10-story building before coming to rest. At NASA's Jet Propulsion Laboratory in Pasadena, which is mission control, this is when the fun really begins.
On the first day, we will get a panoramic image to flash to the world. Everybody's going to be interested as to what the site looks like. And we are striving to get the rover off the lander the first day.
Using rechargeable solar batteries, Sojourner will spend at least a week analyzing a variety of rocks believed deposited in the area by a torrential flood eons ago.
It sits there for 10 hours and slowly figures out what the elements in that material are and determines them down to a fraction of a percent.
The lander is designed to operate much longer, providing more pictures, Mars weather reports, and a wealth of science. Planetary scientists say Pathfinder may rewrite the book on what we know about Mars. And although its instruments aren't designed to detect life, it could provide tantalizing clues as to whether Martian life ever was or still is possible. Just days before its hoped-for historic landing on Mars, the mission team says all systems are performing remarkably well on board the Pathfinder spacecraft.
We're all actually pretty confident. The cruise part of the mission has gone so smoothly that we have a lot of confidence in the spacecraft.
During a briefing at NASA's Jet Propulsion Laboratory in California, usually reserved scientists were remarkably giddy over the smoothness of the mission so far. The vehicle's latest position puts it on a course for a bullseye landing July 4th.
We are now heading directly into the center. The navigation team on Pathfinder really deserves credit for nailing this landing site.
Pathfinder is expected to come to rest in what scientists believe is a relatively flat area containing numerous small rocks. Many of those are thought similar in age to the Mars meteorite found on Earth, which may contain evidence of past primitive Martian life.
It's the first step in a long-term Mars exploration program for looking at whether or not life could have started on our neighboring planet.
Neither the lander nor the Sojourner rover are capable of detecting life, but could tell whether the necessary ingredients for life are present or were ever present on Mars. Much of this project is a test of new technologies, 25 in all. So scientists say the mission will be considered a success if Pathfinder just lands safely and sends back one picture. The biggest concern for the team is whether the airbags used to cushion the landing will work. If they don't, the landing would be a disaster. And that, scientists say, is something they're not looking forward to.
We will be bummed out, to say the least.
John Zarella, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
Our guest is Professor John Logsdon. He is the director of the Space Policy Institute at the Elliott School of International Affairs, part of George Washington University. Well, give us a sense of what's happening right now. We're 3 days away. What's happening now on that mission?
Well, this is going, you say, faster than a bullet. The whole spacecraft, which was launched from Earth on December 4th of last year, is going at a very high rate of speed towards Mars for basically a literally crash landing on the surface. It's not going into orbit or anything. It's going to go straight into the atmosphere, slow down from 12,000 miles an hour to a few feet a second. In less than 8 minutes, parachute, then the airbags you just saw hit the surface of Mars, bounce 10 stories high a few times, and eventually come to rest. Then the airbags deflate, and inside the airbags is this little spacecraft which will open like a flower, 3 petals. Inside will be a lander and a little rover called Sojourner, which will then, a few hours later, set out to explore the immediate vicinity. Neat stuff.
That'll be happening on Friday. Now, this little rover, how big is it?
It's about the size of a microwave, 35 pounds or so. So it is a small craft.
What can it do?
It can go about 500 meters in any direction. It can show us images of the terrain it's seen, and then it has a spectrometer, a fancy name, for something that can measure the chemical composition. So it can roll up to a particular rock and take that rock's profile, if you want. So we will learn what the elements of the surface of Mars at this is an ancient river mouth. And so this, we think, is rocks that have rolled down over the millennia. So it should be a very mixed set of rocks of kind of the history of Mars.
Is that why they've chosen it, especially given the suspicion that there might have been life there a long time ago?
One thing that should be clear is this mission is not going to do anything that will help us confirm or not whether there's life on Mars. It was designed before last year's findings. It's because Mars is such an interesting place, and the evidence of past water is one of its interesting phenomena. So, and this is a relatively flat area. So all of those are the reasons I think that the landing site was chosen.
What are all the risks and unknowns of this mission on Friday?
There are lots and lots. Very little of this has ever been done before. It is, as John Zarella said, primarily a test of new technologies, because this is the first mission in a decade or more sequence of exploration of Mars. So any one mission isn't going to do everything, and that's the point. This thing has to be able to slow down. You have to, the lander is going to rappel down a tether, so it's below a parachute. The parachute has to separate at the right time. You need an altimeter to know how far off the surface you are. Then these airbags have to inflate lots and lots of things that will happen.
And that is to prepare for future missions?
Exactly. If we're going to explore with robots the surface of Mars, we need to establish how to control them, how to pick out good samples, because ultimately we want samples of Mars back in laboratories on Earth.
And this is going to beam back pictures and images and data?
Well, both the lander will stay in one place and this rover have cameras, the better cameras on the lander, and it can take a 360-degree stereo view in a lot of different spectral bands, so we'll get lots of looks at the surface of Mars.
You excited?
Oh, very much so. This is discovery.
Find out. Our thanks to Professor John Nogston of George Washington University. He's the author of The Decision to Go to the Moon, Project Apollo and the National Interest, and he edited the series and Exploring the Unknown, documenting the evolution of the U.S. space program. Thanks.
Thank you.
When Pathfinder lands on Mars, we do what any tourist tends to do when he arrives at a new place. We start out by sniffing the atmosphere, turning our gaze to the sky and seeing what the weather is like. We look at our surroundings, and then if that suits our fancy, we get in our car and drive off and go exploring.
When we get to Mars, we're really excited as to what we might see. Nobody at this point can predict what's going to be in our field of view, and of course, that first look is all important.
Stay with CNN for extensive coverage of the Pathfinder mission and its scheduled landing on Friday. Are we alone in the universe? It's a question that has haunted us since the dawn of mankind. Well, CNN's Jim Hill reports Earth's closest planetary neighbor, Mars, has always been at the center of that question. And even though a probe will land on the red planet Friday, it will be years before the question of life on Mars is answered definitively.
The Earth's closest planetary neighbor, Mars has intrigued us with a question of universal importance. Is the red planet a dead planet, or was there life? Last summer, scientists rocked the world with a chunk of Martian rock, saying it could show signs of primitive life.
We're here today to open the door just a little bit, to provide exciting scientific findings, to tell a fascinating detective story, and to lay out compelling clues that lead us to the direction that we think life might have existed at some point on Mars.
Under powerful magnification, they saw not little green men, but globs of carbonate, a possible sign of past life.
If I weigh it up in my own mind, I'd say the evidence is leaning more towards the sort of pro-life, if you like, attitude.
But other scientists began to chip away at the findings, literally taking pieces of the Martian rock to make their own tests.
I'm, at this point, leaning against the fact, or the observations that lead to the conclusion of biological signatures in this rock.
Leshin and other researchers at UCLA concluded the globules were probably formed by temperature extremes, far too harsh for life.
We're also talking about varying temperature. There's no organism on Earth that lives from 0 to 100.
Not so fast, argued Stanford researchers.
Lots of the rock formed at high temperature. Real question is, did these carbonates form at high temperature?
Other scientists re-examined a second key finding. There are worm-like forms inside the rock that look like fossils of microorganisms. Or do they?
These things aren't even big enough to contain a single strand of DNA on their inside, so it's pretty tough to understand how they could actually be alive, have been alive at some point.
Most scientists agree the rock is Martian and was probably blasted into space by an asteroid millions of years ago. It found its way to Earth and was discovered in Antarctica. No matter what they think about the Martian rock, many scientists are still convinced that if life existed or exists someplace other than Earth, Mars is the best bet. It's roughly the same age as Earth, has an atmosphere, gravity, and signs that it once had water. Pathfinder will be nestling down amidst the Martian rocks and soil. But will it answer the big question?
This mission, Pathfinder, is not looking for life, because we know that if there is life or there was life, it's really, really hard to find, and we're not going to do it on the surface. We're going to have to bring pieces of Mars back.
Main engine start, T0 liftoff, and we have liftoff of AC.
That type of mission is not planned until at least 2005, but there's always the rest of the century.
I think 21st century is going to be about the whole idea is a human species, a single planet species or a multi-planet species, and it's at Mars will determine it.
Jim Hill, CNN, Los Angeles.
From CNN International, this is World News.
Good afternoon from the CNN Center in Atlanta. I'm Jonathan Mann.
And good evening from London. I'm Hillary Bowker. Coming up on this edition of World News, making contact. Just minutes from now, the Mars Pathfinder will attempt to land on the red planet.
And practicing contact. Russia's cosmonauts simulate repair work for the crippled Mir space station. Thanks for joining us. This is one of those moments scientists have been waiting for. Like nervous parents, they've been watching the Mars Pathfinder move through millions of kilometers of space headed to the red planet. And right now, the spacecraft should be approaching its final descent. Joining us to explain what to expect is Kurt Grimaud, a professor of aerospace engineering at the University of Oklahoma. Professor, thanks so much for being with us. You and your team have prepared some sophisticated animations. Talk us through these last few minutes as Pathfinder makes its way to Mars.
Thank you. It's a pleasure being here. The spacecraft is only 7 to 8 minutes from landing on the surface. The animations were done in order to help NASA and JPL instruct the people around the world about what is actually happening. It's impossible to put a camera up there in space and be able to show it real time, and so the next best thing is to have photorealistic animation done.
Okay, so now this package coming from Earth is whizzing towards Mars. I think we can see it there. What are we watching?
Yes, this is just before the tether gets cut and the rockets on the back shell gets fired to get it out of the way. You'll see those fire there. That's simply to get the parachute out of the way as the airbags have been inflated, moving down to the surface, and it's bouncing along the surface, trying to come to a rest.
How high is it bouncing right now?
It can range anywhere from 3 or 4 stories high, maybe up to 6 or 7 stories high. The gravity on Mars is only 1/3 that of Earth. The most important reason why it bounces a lot is that those airbags are like super balls, that they're made out of a very stiff material that is highly inflated, and it'll bounce very high.
What is going to happen now? The thing will come to rest and take us through what they're hoping will happen.
After 5 to 10 minutes, it'll finally come to a rest. It'll take over an hour to deflate and to retract the airbags. As that has been come to a stop, there it shows the airbags deflated. After they're deflated and pulled back in, then it tries to open itself up. And it doesn't matter what side or what pedal it lands on, it'll always ride itself back up. The reason the airbags had to be pulled in is so that when the rover moves off one of the pedals, it will not get tangled up in the airbag.
So is this a sure thing? It looks like they've thought it pretty well through. Are they very confident that this is going to work and everything's going to make this enormous journey without any problems?
They are as confident as you can ever be with a space program. There's always something that could possibly go wrong. They've done extensively testing, both on Earth and especially test chambers for bouncing of the airbags and opening up the pedals and having the rover move off.
Now, while we're talking, we're watching this move ahead. We're looking at the rover. Is this going to happen as quickly as all of this? Is this expected, the rover, to start moving within just the next few minutes?
The rover is the very last thing that will happen on the initial day if everything else goes correct. So it'll take over 12 hours before the rover actually will leave the pedal, if it's in a condition to do so.
Right now, the Pathfinder is still on its way. We have seen it land. It looked like it was coming down rather gently, but it's going very fast now, isn't it?
Yes, it is. It's going 7.5 kilometers per second. you can travel a lot of distance in 1 second, 7 kilometers. When it comes through the atmosphere, it'll slow down to 500 meters per second. The parachutes will open, and after that, it'll slow down to maybe 40 or 50 meters per second. When it impacts the surface, it'll be going at about 30 to 40 meters per second, and that's one reason why it bounces so much. It is moving the speed of a car when it hits the surface.
We're going to go now to the Jet Propulsion Laboratory in Pasadena, California, and listen in because they're hard at work there and awaiting news of the landing as well. Let's listen in. I'm curious about something while they're working and waiting. They're now just 3 minutes away from there.
In about 15 seconds, the events will follow will occur in rapid succession under the control of the onboard software. I'll report these events as they are expected to occur.
If you're just joining us, we're now approximately 2 minutes and 20 seconds from the landing that's been scheduled.
As this landing takes place, it's very difficult to get this information back as it's going through the atmosphere. Some of the radio waves may not be in full power and be able to get receptions, but it seems at this point that they are getting information back as it's going through.
It's easy to take all of this for granted. We're so used to seeing pictures from the space shuttle. We're so used to seeing pictures from the space shuttle, but really they have very little information.
Slowing down rapidly because of parachute deployment. The heat shield should separate in about 3, 2, 1, 0 seconds.
After the heat shield separates, the parachute is slowing it down. The airbags.
The next event is lander separation. That should occur in about 5 seconds. When that occurs, the lander will descend in about 10 seconds down the bridle. Lander separation should have occurred right about now.
You'll notice they say should a lot. Many of these information is pre-programmed, and they're not exactly sure when it's actually happening.
We should be switching from one antenna to another antenna under a flight software control. This is an antenna that proves our ability to see the signal during this descent phase.
So is any human being now in control of this?
No, it is not.
Is any earthbound computer now telling them what to do?
No, the best we can do is get information back from the spacecraft, and that in itself is difficult.
This is an autonomous entity that's acting on its own intelligence and all of the machinery they could put inside, but it's far beyond anyone's ability to help or control.
I'm not sure if I'd say intelligence, but it's programmed. It's a computer that has a sequence of events that it's following.
While we're waiting, and while they're waiting, I've got a question for you.
The spacecraft should be approximately a mile above the surface of Mars. There's a lot of uncertainty in the timing from here on out because of the variation in the atmosphere.
The atmosphere, this is my question. Mars, if I've read correctly, has an atmosphere only 1% as dense as Earth's. How does a parachute work when there isn't air or something to slow the craft down?
Very good question. It does not work hardly at all, but it does add some slowing, so they use it. If they would work like a parachute on Earth, they would not need the airbags to bounce along. They could just do a gentle drop.
Okay, let's listen in now. I'm just struck by what we're seeing now. This is a moment that they've been working for years, but it comes down to a bunch of guys, ladies and gentlemen, walking around with their arms folded and their hands in their pockets, waiting for news like expectant fathers.
It's a very good analogy, is you have to receive information, you cannot help it in any way. What's going to happen is going to happen, and all you're doing is finding out if it was successful or not.
Correct me if I'm wrong, I am told
that a signal is barely visible.
They are getting the signal back. That is great.
It's a very good sign, everybody.
The signal has been received. It means that the spacecraft is intact. At least it has enough information to be able to send a signal out. It does not mean that everything is operational. That will only tell over the next 12 hours as they start testing each piece of equipment, getting the big antennas out to be able to broadcast pictures.
But what you're seeing now is, as close as we can show you, visual evidence that Pathfinder has landed in one piece with at least enough of its technology intact to phone home and tell everyone that it is okay.
Yes. Now the real fun begins, where you start doing engineering experiments, science experiments, to find more information about Mars, the planet itself.
Now, there was enormous confidence going into this mission that this was going to work. In the last few days, we saw some very confident scientists saying that they really were feeling very positive. But in terms of engineering and science and the hard work that these people do, how hard has it been to get something successfully landed on Mars?
It's probably as difficult as any mission has been. The nice thing about this one is it's a smaller one, it's compact. These people are much closer together. It is like a small company coming out with a new wonderful program. They've all worked very hard. It's a lot of energetic people trying to pull this thing off against a lot of odds. And you get very nice products and success when you have that kind of a group working together.
As it would expect it to do after it rolls to a stop.
What?
We are now in a blackout situation where the spacecraft will essentially begin to retract airbags. This process takes a little over an hour. Hopefully, we may see a signal when that finishes up. We will keep our eyes peeled, of course. Seeing a signal from the surface of Mars is actually the hard part.
The signal is extremely weak, and for them to be able to receive a signal is difficult and a wonderful thing to have.
What was the signal that made them so excited? Was it a little beeping noise? Was it a computer entry physically or technologically? Exactly what did they get?
It's almost like the static you would have on the FM radio, and the level of the static will tell them some information. That is about all that they're getting. The static is enough different than the normal static that they can identify that it was a signal made from Mars.
It's an extraordinary thing. Something created on this world has now gone to another world. Let me ask you, we can't get a sense of it watching these gentlemen in their air-conditioned quarters, but what kind of conditions have greeted Pathfinder? Is it cold? Is it hot? Is it dark? Is it bright? Is it sunny? Do we know what the weather is like there?
They landed in the night side. It will dawn in about 3 more hours. At nighttime, it can get as cold as 100 degrees centigrade below zero. The warmest it'll get is about 40 degrees above 0 centigrade. So it's very cold. They have to have special warmers in the rover and in the lander to make sure that the electronics continue working and that the battery power will be conserved.
One of the extraordinary things looking at this is that these experts are really as close as anyone has ever come to Mars. They're doing this extraordinary project. Oh, let's listen to what they're saying. These are the greatest living experts on Mars, one would imagine. How much does anyone really know about that planet?
The duration of this signal should tell us a little bit about what the software thinks the spacecraft is, how the spacecraft is oriented.
20 years ago was the last time we had significant information come from Mars. So it's over 20 years since we have any new information other than what the Hubble telescope has been able to give us. So we only know maybe 2 or 3% of what Mars may have to offer to us over the next 20, 30 years as we send 10 more missions to Mars.
For those who are interested, the spacecraft successfully fired off 41 pyrotechnic devices. All had to work perfectly on the 4th of July.
Yield Telecom reports solid-state power amp off.
Those pyrotechnic devices blow bolts so that the airbags can be retracted inward. You can't get up there with a wrench and unscrew things. You have to have small explosions to unlock bolts and to get things to start working.
They noted with glee that this is, of course, the 4th of July.
Communications folks to calculate how long that signal was active. Maybe give us an idea how long what orientation the spacecraft is in. The signals that are possible are either you're on the base pedal, which means that the spacecraft does not have to roll over, or it's on a side, in which case it will right itself automatically.
We have a model. You have kindly brought a model of the landing craft. I don't know if we can get a tighter picture of it, but if we can, why don't we put it, there we go. We're moving in and out of the shot, there we go. Show us what it is that is going to happen. There was some talk about the pedals and about whether they would be able to...
This is the heat shield that went through the atmosphere and was discarded. This here is what landed on Mars. It does not have the airbags around. Currently, it's sitting on Mars in some configuration with large airbags on the side. Those are now being deflated, and they'll be pulled into the surface. After about 3 hours, these leaves or petals will open up.
An ingenious thing about them, I'm going to interrupt you, they didn't know which side it was going to land on, and that's part of the design here. Show us...
That's correct. The way this thing was designed is that it could land on any one of the petals, and it will correct itself with these motors that open up the leaves. They're strong enough that they can turn the whole lander around, and then the other 2 leaves will open up. There's only one concern that they may have, and I'm sure many of the people watching may also ask, what happens if it lands on its top? How does it open up? This is like trying to balance a pencil on your finger, and it's more than likely going to tip over. If it does not, they can jiggle these leaves to try to jar it off to one side and fall over.
So one of the things they're waiting to find out right now, I guess, is how it's landed on which side.
That's correct.
There was also some talk about the craft itself orienting itself. How does it do that in a strange world? It doesn't know where it's facing, it doesn't know how it's landed. How does it figure out and tell the experts back home where it is?
The best way to orient yourself in space is to be able to know where the sun is. After the airbags have been retracted, the petals have been opened, this camera device here will start moving around and look for the sun. As soon as it locates the sun, then it knows exactly where it's at, what angle it's at, where the Earth is at, and it can send up their high-gain antenna here to be able to get high-speed transmission back to Earth, and that's when the pictures will actually start being sent.
This relates back to some of the delay that we've been hearing about because, once again, as you've mentioned, it's night on Mars right now.
Yes. When these petals are open, it'll be around dawn. That's when they'll have the low-gain antenna try to communicate to Earth. After that, then they will use the camera to locate the sun, tell them where to point the high-gain antenna. After they get the high-gain antenna working, they can transmit back nice pictures to look around to see what the environment is like. If that's successful, then they'll contemplate sending off the rover off the pedal and move just a few meters away from the lander, and that would be a very successful first day if they can get that lander off, or the rover off the pedal.
For the time being, enormous technology, enormous effort that now rests on Mars in a bundle of balloons, and they're waiting for the sun to come up. Professor Grimal of University of Oklahoma, thanks for being with us. Stay with us. We're going to have to take a break, but we'll be back in a moment.
Spacecraft has landed base pedal down. What are the odds? No speculation.
NASA scientists have reason to cheer. The Mars Pathfinder has landed on the red planet. The entry, descent, and landing about half an hour ago went exactly according to plan. The U.S. spacecraft parachuted through the red planet's atmosphere and landed on an airbag cushion. NASA received signals from the spacecraft as it entered Mars's atmosphere and as it landed, but is not to receive any more communications from the Pathfinder for a few hours. The spacecraft is to release what's known as the Sojourner rover, that vehicle designed to creep along the terrain and send pictures and data back to Earth. Scientists have been nervously waiting this event, but one of the scientists who's been careful enough and kind enough to join us to talk about it is Kurt Grimal of the University of Oklahoma. Thanks for staying around to talk to us about it.
Thank you.
If you were watching before, we broke away to go to commercial and then went to a live picture from the Jet Propulsion Laboratory where scientists cheered for a new reason. They were told that the Pathfinder had landed on the base pedal. What is it that made them so happy about that?
Here is a model of the lander as it's currently resting on the surface of Mars. The only thing missing is the large airbags that have deflated and they're going to be pulled into the pedals. There is 4 different sides to this. This is called the base, because if it opens up on the base, the other pedals will go off to the sides, and the base has the main equipment at the center.
So if they're rolling the dice, and this is a 4-sided dice, they got the best possible roll, I guess.
Yes. Another option would be on one of the pedals, in which then it would have to correct itself, which is a little more tricky to do. They certainly designed it for that, but by having it land on its base at the first time, it solves a lot of other problems.
Now, we're looking at this little model. It's a cute little thing. Give us a sense of the real scale of this. How big is the total package and the crucial rover on which so much rests? How big are they?
Well, to compare it to my hand here, this is a 1/10 model, so it would not be much bigger than the size of this table when it fully opens up. This rover itself is no bigger than a microwave oven. It's approximately a half a meter long and 1/3 meter wide and only maybe 20 centimeters high.
So this has been traveling through hundreds of thousands of kilometers of space, essentially to get something the size of a child's wagon to Mars, or
Yes.
smaller.
But that's the nice, exciting thing about this, is every child in the world can relate to their own little remote-controlled toy that many of us have played with in our younger years. This is about the same size. And just like we would play with a remote-controlled toy, the NASA engineers now get to play with their $25 million remote-controlled toy.
Well, I want to ask you more about that. Are they literally, is there one lucky kid at NASA sitting with a joystick that's going to be telling us where to go?
There's 3 or 4 that will be operating the rover, but it's not quite like when we were young and we would push it forward and immediately would go forward. There is a 10-minute time delay, so that if we say go forward, in 10 minutes it'll go forward. If there's a cliff and we say stop, 10 minutes, it'll stop, hopefully not going over the cliff. Because of those problems, they have to have a lot of the intelligence built right into the rover. So it'll point to a direction and say, we want to go look at that rock. The rover has enough computer power and enough decision-making ability to be able to know the right path to get to that rock.
Now, as we're looking at this model, I don't know if, well, we can see the picture. Those beautiful blue things, that's not just a colorful covering, is it? That's actually going to be an important part of the operation, the blue surfaces that we're seeing.
That's a solar panel, and one of the critical things about this mission is the power. They don't have enough, and they try to get as much power as they possibly can, so the whole top surface is a solar panel. That solar panel will help operate equipment on the rover. It'll also charge the batteries that are on the rover. Without that, they will not be able to have an extended mission. There is enough power in the batteries to go 7 days, but if they want to go beyond the 7 days, they're going to have to draw heavily upon these solar panels to recharge the batteries and to keep it going.
Right now, though, once again, it is a cold night on Mars that has welcomed the rover and the Pathfinder. Dr. Kurt Grimaud, I hope you'll be with us some more in the hours to come. I am told you will, to explain all of this mission as it proceeds. For now, we thank you very much for your expertise.
Thank you.
Hillary?
Well, John, you know your kids are going to want a copy of this little rover. And it's not just a $25 million toy. It is, of course, the focus of Pathfinder's mission, and it is supposed to collect and chart data from the planet's surface. Well, it will be done from the Sojourner buggy, as we just said. And CNN's John Zarella is going to report on how that vehicle came about.
There have been big ones. There have been little ones. For years now, rovers of all sizes and shapes have run over rocks, cruised along desert landscapes. They've been tested and redesigned over and over again. Finally, this. Sojourner is what engineers and scientists chose to send to Mars. This is where much of its testing took place, the sandbox at NASA's Jet Propulsion Laboratory in California. Sojourner, a 6-wheeled, 23-pound solar-powered rover, is the centerpiece of NASA's Pathfinder mission.
This will be one of the first images we'll get down from Mars. This is obviously of our test bed, but what we want to look at is make sure that these airbags are underneath where the ramp would deploy here.
If the lander and Sojourner survive the airbag landing on Mars, Sojourner will begin its snail's pace crawl across the surface. Once it finds a rock scientists back on Earth find interesting, the rover's alpha proton X-ray spectrometer will spend up to 10 hours analyzing the composition.
The rover stops the last thing of the day, puts the spectrometer on the rock or on the ground, and it just collects data all night long, and then by the time the sun comes up the next morning, the rover's ready to go off and move again.
With the ability to analyze 1 rock a day, engineers and geologists hope the little vehicle just keeps on going and going. This is the Mars Yard. Scientists and engineers here have already forgotten about Pathfinder and are working on the next generation of Mars rovers. This is Rocky 7, the latest in mini rovers. It looks like Sojourner, but is far more autonomous.
As a rover in the future moves away from the lander, it needs to be able to look at the terrain all by itself and tell itself where to go.
Rocky 7, or something similar, will fly to Mars in 2001. It will gather rocks and wait there until 2005. That's when NASA plans to send a vehicle to pick up the samples and bring them back to Earth. John Zarella, CNN, Pasadena, California.
Fascinating. Well, the surface of Mars may be a subject of intense scrutiny to scientists, but to show business, well, it's well-charted territory. CNN's Dennis Michael looks at the view of Mars from Hollywood.
Just how long have we been receiving these mysterious signals from outer space?
We've been hearing from Mars since the silent movie era and giving about as much respect to our planetary next-door neighbor as the Ricardos gave the Mertzes.
Mars is about to run out of air.
Since Lobstermen from Mars is a humorous movie within a movie, presumably its makers knew that there is no air on Mars, but higher-class writers have made that mistake as well. Ray Bradbury even provided the red planet with a breathable atmosphere in his fantasy anthology, The Martian Chronicles.
They introduced me out at Caltech and say, here's the guy that put oxygen on Mars, huh? And it doesn't exist. But they accept it because they're romantics, too.
In fact, storytellers, and Hollywood in particular, have turned the canals and plains of Mars into something of a Rorschach blot. Look at Angry Red Planet, which says a whole lot more about Earthlings than it does about any Martians.
Mars is also a place where we've projected our fears, our concerns, our dreams, our hopes. Mars is many things, and it should be many things. It's a symbol as well as a planet.
The planet named after the god of war has certainly declared war on Earth many times, from War of the Worlds to Invaders from Mars, and even beach movie regular Tommy Kirk had his turn as a Martian in what may have been the lowest point in Earth-Mars relations. Mars needs women.
The exotic dancer is secured.
The Martians invaded as recently as last winter with Tim Burton's Mars Attacks, but that time at least the Martians had a sense of humor.
Martin, where are you? On television.
It wasn't an invasion from Mars so much as a reconnaissance mission when My Favorite Martian established a beachhead on television in the 60s. Incidentally, a My Favorite Martian movie is now in the works. Now, however, most science fiction writers know Mars is a place to be invaded rather than the source of invaders. Arnold Schwarzenegger, for example, led a revolt of Martian colonists in Total Recall. Mars is, after all, part of the local neighborhood.
If you look at an image taken from the surface of Mars, it's Death Valley. It's so familiar. We've been there before. We feel that we know. It's not like Venus, which is so obviously unhospitable and alien. There's a kind of homey quality to Mars.
That is, as long as you remember to bring your own air. Dennis Michael, CNN Entertainment News, Hollywood.
I loved all of those movies.
Bowker in London. Beam me up, Johnny.
Jonathan Mann at the CNN Center. American edition is just ahead.
Guten Abend, meine Damen und Herren. Nach 7 Monaten Flug ist die amerikanische Sonde Pathfinder auf dem Mars gelandet. Kurz nach 19 Uhr erhielt das NASA-Kontrollzentrum in Pasadena das Bestätigungssignal. Ob sie die Landung unbeschädigt überstanden hat, erweist sich erst in den nächsten Stunden. Dann geht auf dem Mars die Sonne auf und Pathfinder erhält Energie für ausführlichere Datenübertragungen. Es ist die erste Landung eines Raumfahrzeuges auf dem Nachbarplaneten seit 21 Jahren.
Jubel im Kontrollzentrum in Pasadena, Kalifornien. Jetzt hoffen die Wissenschaftler nur, dass die speziell entwickelten Luftsäcke den Aufprall so gut abfederten wie in dieser Computersimulation. Sofern alles heil blieb, spielt sich auf dem Mars jetzt diese Szene ab. Die Kapsel richtet sich auf und entfaltet ihre Sonnenpaddel. Diese Nacht soll die Sonde ihre ersten mit Spannung erwarteten Bilder zur Erde funken. Ob es wirklich einmal Leben auf dem Mars gab, darauf werden auch die neuen Bilder vom roten Planeten keine Antwort geben. Aber die Wissenschaftler hier im Kontrollzentrum im kalifornischen Pasadena wollen auch etwas anderes, nämlich herausfinden, wie gut oder schlecht die kleinen Rover auf der Marsoberfläche rangieren können. Dieser Rover ist das Herzstück der Mission. Auf ihrem sogenannten Mars-Übungsplatz hat die NASA ihn getestet. Mit dabei deutsche Wissenschaftler, die die Optik der Sonde entwickelt haben. Dass die NASA die Landung genau auf den amerikanischen Nationalfeiertag gelegt hat, begrüßen sie.
Ich finde es sehr geschickt.
Und weil das auch wichtig ist für uns alle. Das ist ja nicht nur für Amerika wichtig, Erfolg zu haben, sondern es ist für alle Leute, die in der Raumfahrt sind, auch in Europa wichtig, Erfolge zu haben, weil wir dann Anregungen bekommen und weil wir dann auch die Politiker anregen können, eben finanzielle Unterstützung zu geben.
Um den Politikern diese Unterstützung schmackhaft zu machen, hat die NASA jetzt das Motto: billiger, besser, schneller.
Thank you for joining us. On this edition, the thrill of victory, the enormity of defeat, scientists celebrate the Pathfinder mission landing on Mars. Time in over 20 years, we should soon be getting a ground's-eye view of Mars. After a 7-month journey, the Mars Pathfinder has landed on the surface of the red planet just a little over an hour ago. Padded by a cushion of airbags, the Pathfinder bounced to a halt and signaled NASA controllers all was well. The news prompted cheers from the scientists at NASA's Jet Propulsion Laboratory in California. They grew louder and more excited as it became clear Pathfinder has landed in the optimum position. NASA should start receiving the first pictures from Mars in about 2.5 hours. And joining us from Atlanta to help us with the Pathfinder story is Kurt Grammel, aerospace engineering professor at the University of Oklahoma. He and his multimedia company helped develop the animation we've been using in our coverage of this event. Well, Dr. Grammel, give us a sense of what an achievement it is. It has landed and in the right position.
It's a wonderful day. You need to remember it's been 21 years since we've had any lander on Mars, and furthermore, the 3 or 4 missions that have been sent up over the last 20 years have failed. And so it's been a kind of a jinx or a girl that has been out in the space grabbing these spacecraft. So finally have one landed is just fabulous.
What do we actually know in terms of the condition of the Pathfinder, how it is and where it is?
All we know is it's not in a million pieces. It is in one piece. It's sending back a carrier wave, which is a signal letting them know that it's alive and it's starting to do its operation of pulling back the airbags, and then it'll open up the pedals. And it won't be for another 2 to 3 hours before we can communicate with it and send it information requesting engineering data to be sent back.
Once that opens, what happens then?
Well, I have a model here that I'd like to illustrate what will happen over the next day. Here is the lander, and it originally landed correctly straight up, which was wonderful. The pedals will open after 2 hours. After it becomes open, then the low-gain antenna will send a signal out trying to locate the Earth, communicate with Earth. Earth will come back and tell it that it's where it's at. At that point, it'll take a camera picture of the horizon trying to find where the sun is. Finding the sun is important. It'll give the location of the spacecraft so that it can point its high-gain antenna. The high-gain antenna will allow it to communicate much quicker and faster. After the high-gain antenna is pointed directly back to the Earth, the camera will once again be activated and be able to take black and white pictures and then later color pictures. If that all goes well, then they'll make a decision whether to send the rover out off the pedal into a nearby area to start analyzing the soil. But that'll be the last thing that will be accomplished today if everything else goes well.
The question is, this was above all a test of technology. What have we learned so far?
Well, the airbag technology works. That the lander did not break into a number of pieces, that it's landed on Mars. The next part of technology that will be tested is actually the rover, to be able to get it off the panel and be able to move around and analyze soil. Those are the 2 big engineering feats that they're trying to prove on this particular landing.
Now, that rover partly moves around with its own artificial intelligence and partly it's told what to do by remote from the scientists in Pasadena, California.
Yes, it's a nice mixture of both. The reason why they cannot totally control it is because there's a 10-minute time lag. If it was heading towards a cliff and they were being remotely controlled and you said stop, it'd take 10 minutes before it stopped and it could go over that cliff. So they have to have some type of artificial intelligence in the computer so they can make decisions on its own without being told. It'll be told where to go to, but it'll have to figure out how to get there.
How does it figure out how to get there?
There's been a lot of computer scientists programming its intelligence. It has a very powerful computer on board. In the front, there are 5 lasers that'll detect different sizes of rocks, where they're going to, what they are, how big they are, if they should go over them, or whether they should go around them.
Now, the part of Mars where the Pathfinder is, and hopefully the rover will travel around, was very carefully chosen. What's special about this? Why have they chosen this area?
For one reason is they would like to know more about the landscape of where they thought large amounts of water have rushed across the surface or formed rivers. The area here is a riverbed and a delta area. The other reason why the delta area is nice is that it's flat and will have very few craters and large rocks. If it had a lot of deep crevices and rocks and canyons, it could damage the lander when it was bouncing along. Furthermore, it could get stuck and not be able to have the rover go out. So they wanted an exciting site, but yet one that was relatively flat and rock-free.
Thanks to Kurt Rummel, Aerospace Engineering Professor at the University of Oklahoma. Pictures should be arriving within the next 2.5 hours from Mars. Our guest will also be appearing on Insight Special, Exploring the Red Planet. How do we do it? That'll be Insight on CNN, also about 2 hours from now.
7 Mars-Tage, 24,6 Stunden lang, wird der Roboter den roten Planeten erkunden. Sein Forschungsauftrag: kartieren, messen, analysieren. Die NASA erwartet weitreichende Erkenntnisse zur Geologie, Geochemie, Klima und Atmosphäre des Planeten. Wichtigstes Gerät: der Alpha-Proton-Röntgen-Spektrometer, kurz APXS. Er tastet Staub ab, entnimmt Gesteinsproben und analysiert deren chemische Zusammensetzung. Doch die Mission Pathfinder sucht nicht nur nach Spuren früheren Marslebens. Navigationssatelliten sollen die Marsoberfläche umkreisen und kartografisch erfassen. Magnetische und Gravitationsfelder sollen genau untersucht werden. Spezielle Wetterballons vermessen das Klima des unwirtlichen Planeten. Doch eines ist jetzt schon sicher: einen Beweis für Lebensformen auf dem Mars wird auch die Pathfinder-Mission nicht erbringen, denn der Roboter kann keinerlei Proben aufnehmen und auf die Erde mitbringen. Ein Trost: das nächste Projekt ist schon geplant. In einer zukünftigen Mission soll Nomad, ein Roboter so groß wie ein kleiner Jeep, den Mars weiter erkunden.
Ja, der Skateboardfahrende Schuhkarton, der Sojourner, das eigentlich beeindruckende technische Kapitel, also die mobilen Roboter, wie wir sie gesehen haben, die selbstständig in einer unbekannten Umgebung arbeiten können. Das wirklich Faszinierende aber ist der Preis der Mission. Faster, cheaper, better.
Seit 1962 versucht der Mensch, den Nachbarplaneten der Erde, den Mars, zu erobern. Ziel der 22 Missionen, die seitdem auf den Weg gebracht wurden, ist am Ende die Kolonialisierung des neuen Planeten. Wir sind heute technisch in der Lage, Menschen auf den Mars zu schicken. Und wir haben auch bewiesen, dass der menschliche Körper dieser Reise standhalten kann. Die Astronautin Shannon Lucid verbrachte 188 Tage im schwerelosen Raum. Die Russen brachten es gar auf 450 Tage. 35 Jahre haben Amerikaner und Russen dafür geforscht, zu Zeiten des Kalten Krieges zunächst als strikte Konkurrenten. Nur die Hälfte ihrer Projekte war von Erfolg gekrönt. Vor allem die Russen hatten Pech. Obwohl als Erste zum Mars unterwegs, mussten sie immer wieder Rückschläge einstecken. So verloren sie 1962 den Kontakt zu ihrer Sonde Mars 1. Ihren letzten Misserfolg mussten sie im vergangenen Jahr hinnehmen. Ihre Sonde Mars 96 stürzte in den Pazifik. An diesem Projekt waren 22 weitere Länder beteiligt. Jeder Fehlschlag bedeutet neben erheblichem Prestigeverlust auch Investitionen in Höhe von mehreren Millionen Mark, die umsonst sind. Davon können auch die Amerikaner ein Lied singen. Von 6 ihrer Projekte waren nur 4 erfolgreich. Dennoch, zunächst gelangen Fotos der Marsoberfläche im Vorbeiflug, dann wurden erfolgreich Kapseln auf dem Planeten abgesetzt. Später gelang die Übermittlung der Daten von Bodenproben. All diese Informationen trugen am Ende dazu bei, dem roten Planeten Konturen zu geben. Doch was 1969 bei der Landung des ersten Menschen auf dem Mond noch möglich war, ist nach dem Ende des Kalten Krieges schon schwieriger geworden. Nun sitzen alle im gleichen Boot, auch die Russen. Und für alle gilt das Gleiche. Die Kosten, vor allem in Zeiten knapper Kasse, müssen immer wieder aufs Neue legitimiert werden. Falls die ganze Menschheit, nicht nur eine einzelne Nation, sich darauf konzentrieren, Menschen auf den Mars zu schicken, dann wird sie es eines Tages schaffen. Aber ich muss dazu sagen, dieses Vergnügen wird uns alle sehr, sehr teuer werden. Die amerikanische Weltraumbehörde NASA könnte hier mit ihrem Pathfinder einen Ausweg zeigen. Das Projekt kostet mit 225 Millionen Mark nur ein Fünfzehntel der Viking-Mission des Jahres 1975. Außerdem hoffen die Entwickler des Sojourners auf eine baldige Vermarktung ihres Roboters. Und das auf Erden. Cheap, better and lighter, so die Devise der Amerikaner. Aus der Not machen sie eine Tugend und hoffen so auch den Fortbestand der Agentur in das kommende Jahrtausend zu sichern. Und der Zeitplan dafür steht bereits. Zwischen den Jahren 2011 und 2018 soll der erste Mensch seinen Fuß auf den Planeten Mars setzen.
Ja, vielleicht gar nicht mehr allzu ferne Zukunftsmusik. Dr. Gernot Hartmann, kommen wir noch mal auf die jetzt eingesetzte Technik zu sprechen, auf den mobilen Roboter. Der Rover wird ja auf der Marsoberfläche keine Geschwindigkeitsrekorde einstellen, aber dafür, und das ist das vielleicht Unsichere, er bewegt sich auf unbekanntem Terrain. Was glauben Sie, wird er seine Fahrt da unbeschadet überstehen?
Ich glaube, wenn er einmal losgefahren ist, ist er unter so guter Kontrolle, dass er diese Strecken, die er fahren wird, auch unbeschadet überstehen wird. Es ist ja nicht so, dass er nur durch die Gegend fährt. Es wird ja auch vorher bestimmt, wie weit er dann jedes Mal fahren wird. Und da glaube ich schon, das wird erfolgreich werden.
Problematisch sind ja offenbar die extrem kalten Temperaturen. Es ist ja bis an die minus 100 Grad dort kalt.
Das Problem ist sicherlich, dass es am Tag relativ nicht so kalt ist, sondern in der Nacht furchtbar kalt wird. Aber das ist ja etwas, was man vorher gewusst hat und wofür man dann den Sojourner auch thermisch ausgelegt hat, sodass ich da hoffe, dass es dann auch damit funktioniert.
Damit kann man auch etwaige Eventualitäten mit den ganzen Vorhersagen weitgehend ausschließen?
Eventualitäten kann man eben immer nicht ausschließen. Und wir müssen hier in dem Fall, das ist sicher ein ganz gewichtiger Punkt. Vorhin wurden die Kosten genannt, die ein Fünfzehntel einer vorherigen Mission waren. Das heißt, an dieser Stelle werden sicherlich auch ganz andere Risiken eingegangen. Es wird sehr viel weniger redundant, also mehrfach abgesichert ausgelegt, um einfach auf diese niedrigen Kosten zu kommen. Also Risiken sind hier sicherlich enthalten.
Nun ist ja, was ja herausgefunden werden soll, noch mehr, also neue Erkenntnisse über die Atmosphäre, das Klima, Gestein und Staub. Wie detailliert werden denn diese neuen Erkenntnisse wohl sein? Sind das erschlagend neue Erkenntnisse, die man da ermitteln wird?
Jede neue Messung bringt auch wieder Überraschungen. Hat die Vergangenheit so gezeigt. Und ich glaube, die Messtechnik, gerade bei diesem Alpha-Proton-Röntgenspektrometer, was vorhin aufgeführt worden ist eine so weit entwickelte Messtechnik heute, dass ich davon ausgehe, dass hier auch wirklich überraschende, aber aufregende neue Dinge gefunden werden.
Billige, aber trotzdem effektive Technik, das scheint ja bei Pathfinder das Leitmotto zu sein. Wird denn Raumfahrt damit insgesamt für alle Akteure viel erschwinglicher und effektiver?
Ich meine, wir bemühen uns ja an allen Fronten, effektiver zu werden. Das heißt, die Mittel, die weniger werden für die Raumfahrt, so einzusetzen, dass immer noch die Dinge getan werden können, die aus heutiger Sicht so wichtig sind. Insofern ist dieser Kampf um mehr Effizienz an allen Fronten, nicht nur bei der NASA, sondern auch in Europa natürlich im Gange.
Haben Sie erst einmal herzlichen Dank, Herr Hartmann. Wir kommen gleich dann noch mal zurück. Der Mars hat die Menschen von jeher fasziniert. Kriegsgott der Römer oder Unheilsbringer im Mittelalter. Die Astrophysik des vergangenen Jahrhunderts ergab da schon konkretere Eindrücke von dem roten Planeten. Astronomen entdeckten riesige Kanäle, Hinweise auf extraterrestrisches Leben. 1938 versetzte ja das Orson Wellesche Hörspiel War of the Worlds die Menschen in panische Schrecken. Invasion von Marsmenschen auf der Erde. Nun, heutzutage glaubt da kaum noch jemand dran, aber trotzdem ergötzt man sich an noch so kleinen Hinweisen und seien es nur etwaige fossile Spuren von Mikroorganismen, die da im vergangenen Sommer in einem Mars-Meteoriten entdeckt wurden. Die Faszination Mars ist ungebrochen. Thomas Curtius dazu.
Eine rote Kugel im All, kaum mehr als halb so groß wie unsere Erde, eisig kalt. Umgeben von einer dünnen, giftigen Gashülle, der Mars. Dieser scheinbar so trostlose Himmelskörper hat wie kein anderer die Fantasie der Menschen angeregt. Wegen seiner Farbe brachten ihn unsere Ahnen vor allem mit Feuer, Kampf und Blut in Verbindung. Römer und Wikinger verehrten ihn als Kriegsgott. Die Salier huldigten ihm mit Waffenspielen. Im Zeitalter der Aufklärung wandelte sich das Interesse. Die Frage nach Leben auf dem Mars wurde wach. Der Philosoph Kant glaubte fest an die Existenz solcher Marsianer. Er blieb nicht der Einzige. Als der italienische Astronom Schiaparelli 1877 seine berühmten Kanali auf dem Mars entdeckte, hielt man diese für gigantische Bewässerungssysteme. Der amerikanische Multimillionär Percival Lowell ließ ein Observatorium zur Erforschung des roten Planeten bauen. In den 60er und 70er Jahren unseres Jahrhunderts statteten amerikanische Sonden dem rund 180.000 Millionen Kilometer entfernten Mars mehrere Besuche ab. Doch weder beim Überflug von Mariner noch bei der Landung von Viking 1976 ließen sich kleine grüne Männchen blicken. Wahre Fans außerirdischer Existenzen konnte das nicht schrecken. Hatte Viking doch ein Sphinx-ähnliches Gebilde auf dem Mars ausgemacht. Geologen entkräfteten zwar auch diesen vermeintlichen Beweis fremder Lebensform, doch die Anhänger der Marsianer zogen vor einem Jahr ein weiteres Ass aus dem Ärmel. ALH 84001. Ein Marsstein klein und runzlig wie eine alte Kartoffel. Vor Jahrmillionen war er vom Mars abgesprengt worden und schließlich nach einer Odyssee im Weltraum auf die Antarktis gestürzt. In seinem Inneren organisches Material und fossilartige Strukturen. Der Stein geriet ins Rollen. Gibt oder gab es doch einmal Leben auf dem Mars? Die Fachwelt streitet sich wieder einmal erbittert.
Ja, Herr Gernot Hartmann in Augsburg. Die These einiger Forscher, einiger NASA-Forscher, dass es auf dem Mars einmal Leben gegeben haben könnte. Für wie stichhaltig halten Sie diese?
Zunächst einmal gibt es sehr starke Vermutungen, die durch die Bilder von Mars zu begründen sind, dass es auf dem Mars mal Wasser gegeben hat, Wasser in flüssiger Form. Und wir wissen ja, für uns ist Wasser die Grundvoraussetzung für die Art von Leben, wie wir sie kennen. Die Daten, die aus dem Meteoriten gewonnen worden sind, die sind alle für sich einzeln genommen auch anders erklärbar. Zusammengenommen geben sie eine gewisse Wahrscheinlichkeit, dass es auf dem Mars mal Leben gegeben haben kann. Ich glaube erst an Leben auf dem Mars, wenn die Spuren, die wir da gefunden haben, durch weitere andere Beweise erhärtet worden sind.
Wenn wir jetzt diese ganzen Bilder, diese Animationsbilder sehen, dann ist es ja nun wirklich viel Wüste, es ist rote Wüste, Stein und Staub. Da könnte man ja sagen, was gibt es da eigentlich überhaupt Großartiges zu erforschen? Was sind da eigentlich so die wirklichen Bedürfnisse der Forschung, da heranzugehen an diesem Planeten Mars?
Ja, Mars ist ja unser nächster Nachbar im Sonnensystem, ein Planet weiter nach außen. Er hat die größte Ähnlichkeit mit der Erde. Es hat mal wahrscheinlich Wasser auf ihm gegeben. Eine der Fragen ist, warum gibt es heute keins mehr? Warum war das nur eine so kurze Zeit vorhanden vor einigen Milliarden Jahren? Daraus können wir etwas lernen, wie entwickeln sich Planeten in unserem Sonnensystem? Also wie entwickelt sich unsere eigene Erde? Wie ist das in ferner Zukunft, was dann auf unserer eigenen Erde entsteht? Das sind so Fragen, die man da mit angehen wird.
Auch Fragen, die schon fast ins Philosophische gehen. Herr Gernot, Herr Hartmann, wenn man den Fantasien der NASA-Planer Glauben schenken darf, dann werden ja schon sehr bald, irgendwann im Jahre 2010, vielleicht die ersten Menschen ihren Fuß auf den Mars setzen. Ist das unbedingt erforderlich?
Das ist immer diese gute Frage, ist der Mensch im Weltraum überhaupt erforderlich? Es gibt sicher viele Dinge, die wir im Weltraum tun können, ohne den Menschen, mit Automaten. Aber wir bauen jetzt in einer internationalen Anstrengung die Raumstation als Nachfolge von Mir. Dann bringen wir da den Menschen in den Weltraum. Da wird er die Erde umkreisen in einem relativ nahen Abstand, also so viel Weltraum ist das da noch nicht. Wenn wir also uns damit befassen wollen, müssen wir weiterdenken. Wohin soll der Mensch denn im Weltraum gehen? Was sind da seine Ziele? Ist es weiterhin eine Eroberungslust, neue Lebensräume und solche Dinge, von denen die NASA träumt? Ich weiß das nicht genau. Oder ist es nur Streben nach Erkenntnis, die wir ja viel besser gewinnen können, wenn wir selber da sind, die Eindrücke, die wir uns selbst verschafft haben? Sie erinnert sich sicher an den großen Sprung, auch den philosophischen Sprung, den es gegeben hat, als die ersten Menschen die Erde verlassen haben und die Erde vom Weltraum aus als kleine, blaue, empfindliche Kugel gesehen haben. was das auch für uns alle dann für einen Einfluss hinterlassen hat.
Ein gutes Schlusswort. Haben Sie herzlichen Dank, Herr Hartmann, und auf Wiedersehen nach Augsburg.
The moment NASA scientists have been waiting for has finally arrived. About 2 hours ago, the Pathfinder space probe landed on the planet Mars, beginning an extraordinary mission that will carry it across the red planet's surface. But some nail-biting moments remain ahead. CNN's John Holloman joins us from the CNN Center in Atlanta to tell us more about this exciting day in space. John.
Sonia, it is a lot better than we thought it was, even the last time that you and I spoke. We thought the first pictures would be coming up about 4 hours from now. Now it turns out they're going to be coming up 2 hours from now. They've managed to do something. This little robot on the surface of Mars has managed to have more electricity in its batteries than people thought. The sun is coming up on Mars on schedule. Looks like we'll get our first pictures in 2 hours instead of 4. And this was the reaction at NASA's Mission Control at the Jet Propulsion Laboratory when they got an update on how well the Pathfinder mission was going on the surface of Mars. Listen.
We've confirmed that the spacecraft is now completed pedal deployment, and we're transmitting our final semaphore on the low-gain antenna. We now expect to get a signal in the spacecraft at 2:09 Pacific Daylight Time with real digital data. Stay tuned for more excitement from Mars Pathfinder.
These guys are engineers. They're highly technical people in that room, and the fact that they are jumping up and down, hugging each other, is a sign that they are acting very unusually. But so is the Mars Pathfinder on the surface of Mars, joining us to show us what it looks like, show us what is happening on the surface of Mars. Professor Kurt Grammel, now of the University of Oklahoma, but just a few days ago you were at Georgia Institute of Technology, where you came up with a lot of these beautiful animations that we and the folks at the Jet Propulsion Lab have been using to try to explain to ourselves and to people watching how this thing was going to look as it made its way through the Martian atmosphere. Kurt, you heard that announcement from the Jet Propulsion Lab. I hope you did. The
Yes,
word
I did.
was first pictures a lot sooner than we thought. How could that be?
This is just an exciting time. Everything's going picture perfect. And the reason why they've been able to get it out sooner is that these pedals on this model that I have in front of me was able to open up quicker, and thus they're able to communicate back to Earth with this low-gain antenna. And that's what they were so happy about this last round, is that they can now talk back and forth to the landing craft.
And that means they can tell it, okay, go ahead and start taking your pictures sooner than they thought they were going to be able to.
The next big task is to take some very simple readings of where the sun is with the camera. And they won't be photographic pictures, but it'll tell them where the sun is so that they can point the high-gain antenna back to Earth.
So if the thing can see the sun, it knows where the Earth is and can aim the, the big dish rather than the little radio antenna back to Earth and set up a lot of good pictures, I guess.
Without the high-gain antenna, it would take a very long time to send any information such as pictures back to Earth. So they want to make sure they get this high-gain antenna directed back to Earth so that they can get those pictures back to us within 2 hours.
You got a globe of Mars there, Kurt, and this may be a question that you don't have the answer to. I have a much smaller globe of Mars with the landing zone on it. Do you know where on the surface the Pathfinder is on the ground, give or take a few 100,000 miles?
Oh, of course. One of the easiest things to recognize on a globe is there's a large trench area, and it's larger than the Grand Canyon by about 10 times. You locate that, and everything else becomes relative to it. The landing is actually up into this area, and it's kind of a river delta, Arius Vallis, and the Viking landing was only a couple hundred miles away, so it's fairly close to that, and that's one reason they chose that site, is they're a little familiar with this area.
So if they had gone someplace totally different from the Viking landing spot, they might have found, they would have known what?
Well, they could have hit a very large mountain or canyons, and it might not have survived the landing. So they were very worried to get a fairly flat surface so that the landing would be successful.
Yeah. What do you expect to show up in the first picture that we'll see in 2 hours and 5 minutes from now?
It'll be a panorama shot of 5 or 6 pictures towards the direction of the rover, wherever the rover is going to be going off. They want to get some pictures in that area, because once they get the pictures back, the next decision they have to do is, are we going to send that rover off the pedal? And that's what these pictures are for, not for us to look at, it's for to guide whether that rover is going to be able to leave the pedal or not.
Okay, well, let's move our model around toward the camera. So the pictures are going to be looking this way. basically, out here, because this is where the rover is. And the rover has got a couple of little roll-up sort of red carpet tracks that it uses, right? They'll roll out so that it can get, in case this thing was up on a hill, it could go down the side of the hill without turning over, basically.
It's not shown here, but there's 2 ramps that will go out about 3 or 4 meters so that it can make sure it can come off this sharp edge. And also, if the airbags were not totally retracted, it'll go over the top of those. They're very concerned that those airbags have gotten retracted. If it gets tangled up in those airbags, the rover will get stuck.
And that first picture will tell them that as well.
Yes.
All right. So this is the Pathfinder's eye view. It will be looking down here at the rover, make sure it's okay, and further out here in front to just see what's out there for them to explore with the rover.
There will be 2 passes of pictures. The first is a fairly narrow angle. Then there'll be a second pass of pictures that'll give a wider view. And then the decision will be made whether to let the rover go off the first day.
All right. And so if everything else is 2 hours ahead of schedule, does that mean the rover might be leaving 2 hours early?
Very much so.
Wow. So for the scientists, that means I may not have to be here until 2 o'clock in the morning Eastern time. We might have our first pictures before that. It's fascinating. Let's talk about the planning of this mission. I mean, you are sitting here and you know all this stuff. You know that the first pass of pictures is going to be this wide and the second pass will be that wide. This has been extremely meticulously planned, hasn't it?
For 4 years, they've laid down the groundwork, and I was given a mission plan 3 years ago. The reason I was looking at the mission plan is to prepare for the animations. I've also put together an educational CD-ROM for high school and junior high students. I was able to take the information in that mission plan and put it together as an animation.
All right, so school children in the United States and perhaps around the world can get access to your CD-ROM and learn a lot more about this, because that's what we've been using on TV. It's just fabulous video. All right, listen, Kurt, I thank you very much. You're going to be here a lot. You're going to consult with us throughout the rest of the mission today, and we appreciate it at CNN International. So, isn't this good? We've got great guests all over the place to help us understand this.
19:09 Uhr im Kontrollzentrum der NASA in Pasadena. Die Wissenschaftler und Ingenieure sind begeistert. Nach einer 7 Monate langen Reise über 190 Millionen Kilometer Entfernung landete die Sonde mit nur 2 Minuten Verspätung auf dem Mars. Seit über 20 Jahren haben die Raumfahrtexperten diesem Moment entgegengefiebert. Willkommen im Heute-Journal. Ob die Landung der Sonde mit dem schönen Namen Pfadfinder wirklich ein Erfolg war, kann man zum jetzigen Zeitpunkt noch nicht mit letzter Sicherheit sagen. Auf dem Mars geht die Nacht gerade jetzt zu Ende und die Solarzellen der Maschine warten auf den Sonnenaufgang. Dann dauert es noch einmal 10 Minuten, bis das erste Funksignal auf der Erde aufgefangen werden kann. Das Zittern für die Wissenschaftler ist noch nicht zu Ende. Der rote Planet erregte schon immer die Fantasie der Menschen. Aber dass ausgerechnet heute, am Feiertag der Unabhängigkeit, der amerikanische Pioniergeist Triumphe in den weiten Fernen des Weltalls feiert, das hat die USA in einen wahren Marstaumel versetzt. Elmar Thewesen aus Washington.
Amerikas Geburtstagsfeier kommt heute Nacht von allein in Schwung. Dann werden die Bilder live vom roten Planeten auf die Leinwand gebeamt. Bei 35 Grad im Schatten würden manche hier ganz gern tauschen mit dem Pathfinder auf dem kalten Mars. Der Traum, den John F. Kennedy hatte, geht weiter, sagt sie. Er stoppt nie. Begeistert ist sie. Und wie könnte man einen Geburtstag besser feiern?
Good way to celebrate our birthday.
Selbst aus dem All steuert die Crew des Space Shuttle Columbia ihre Glückwünsche bei. Das Geschenk ist auch noch ansprechend verpackt, mit witzigen Airbags, die den Aufprall abfederten. Nach dem Auspacken steht da ein kleiner Rover wie ein ferngesteuertes Auto für Kinder. Nur, dass der Fahrer ihn aus 190 Millionen Kilometer Entfernung lenkt. In einem riesigen, roten Sandkasten namens Mars. alles Absicht. Schließlich will die NASA mehr Geld für weitere Missionen. Sehr passend findet es der NASA-Chef. Wir feiern den Unabhängigkeitstag mit einem Zeichen für geniale Wissenschaft und für ein forschungshungriges Amerika, um die Welt für die Kinder besser zu machen. Ein toller Tag. Selbst Hollywood spielt mit. Solche Überraschungen erwartet die NASA zwar auf dem Mars nicht, aber dass Man in Black gestern im Kino anlief, ist eine gute Werbung. Die hier muss niemand mehr überzeugen. Sie feiern auch Geburtstag. Zum 50. Mal jährt sich der UFO-Absturz von Roswell, New Mexico. Dieses Wesen sei damals mit 4 Kameraden an Bord gewesen. 100.000 Menschen besichtigen es in diesen Tagen. Natürlich ist es nur eine Plastikattrappe. Das Original hat die Regierung verschwinden lassen, sagen sie. Ach, und den Beweis für Leben auf dem Mars, so wissen die Pilger an der Absturzstelle längst, den gibt es schon. Ein NASA-Foto, das Gesicht im roten Planetensand. Auch ein Werbetrick für den Aufbruch zu neuen Ufern? Wir sind immer noch Pioniere, schwärmt Dan Goldin. Wir haben das im Blut. Die Landung auf dem Mars ist mystisch, aufregend und entspricht unserem Forschungsdrang. Insgeheim plant die NASA nämlich Großes. Nach dem Mann im Mond nun Menschen auf dem Mars, der außer Sauerstoff alle Rohstoffe hat, die man zum Leben braucht. In 8 Jahren soll's losgehen, kosten 25 Milliarden $. Aber zuerst muss der Rover einmal da oben das Terrain sondieren, Gesteinsproben einsammeln, nach Spuren für Leben suchen. Vorausgesetzt, alles klappt wie geplant.
In Washington bin ich jetzt mit meinem Kollegen Elmar Thewesen verbunden. Weiß man jetzt, fast 3 Stunden nach der Landung auf dem Mars, ob alles heil geblieben ist?
Zurzeit ist also ein kleines Biepen zu hören, mehr bisher nicht. Aber das ist eigentlich ein gutes Zeichen, denn es kam 2 Stunden früher als erwartet. Und es bedeutet, dass die Marssonde auf ihrem Boden steht, auf der Oberfläche des Mars, also richtig herum. Und von da aus kann es eigentlich jetzt auch relativ bald in einigen Stunden weitergehen.
Also man weiß inzwischen schon sicher, dass alles gut gegangen ist.
Ja, die Sonde ist angekommen, ist gelandet. Die Geräte, soweit man das bisher feststellen konnte, funktionieren. Dass dieses Signal jedenfalls vorliegt, das beweist das. Und was jetzt weiter passiert, ob vielleicht irgendwas in der Technik des kleinen Rovers beschädigt worden ist, das weiß man natürlich erst, wenn er tatsächlich ausprobiert wird.
Wann kommen denn die ersten Bilder, Elmar Thewesen?
Die ersten Bilder erwarten wir hier in der Nacht. Das wird in Deutschland etwa 1 Uhr morgens, 2 Uhr morgens sein, vielleicht auch etwas später. Das hängt davon ab, wie schnell die Kamera ausgefahren werden kann, wie schnell sich die Batterien aufladen und dann eben wir vielleicht einen ersten Rundumschuss von der Landungsstelle bekommen.
Was soll denn diese Mars-Mission eigentlich an Erkenntnissen bringen?
Also es ist eigentlich einfach. Man sucht nach Wasser oder besser nach den Resten von Wasser. Denn das ist ja so ein bisschen der Urstoff für alles Leben. Und man hat im letzten Jahr einen Meteoritenblock genau untersucht und hat dabei Überreste von organischen Molekülen, von Wasserstoff, Kohlenwasserstoff gefunden. Und wenn man das an dieser Stelle auch findet auf dem Mars, es ist ein Ort, an dem es früher mal einen Strom gegeben hat, der ist längst ausgetrocknet. Aber wenn man das dort findet, dann heißt das, dass es vor 4,5 Milliarden Jahren dort Leben gab. Und das würde bedeuten, dass es vielleicht auch andernorts im Weltall ähnliche Bedingungen gegeben hat und eben auch Leben.
Ja, vielen Dank, Elmar Thewesen. Morgen werden wir also mehr darüber wissen.
From CNN International, this is World News Europe with Hilary Bowker in London.
Hello and welcome to World News Europe. Coming up on this edition, our top story, scientists here on Earth cheer the success of a landing on Mars. The Pathfinder has landed. The unmanned spacecraft touched down on Mars about 3 hours ago after a 7-month journey. Now anticipation is building for the first transmission of pictures and the start of the 6-wheeled rover's exploration. CNN's John Harleman, our space expert, joins us now from CNN Center in Atlanta to tell us more. John?
Hillary, this is one of those stories that really plays well on the CNN International Network, and if we had viewers on Mars, they'd be interested in watching it as well. And maybe we do. How do we know for sure? At any rate, the Pathfinder is has plopped itself down on the surface of Mars. Those huge airbags have deflated. Right now on NASA television, there is a picture in a sandbox at the Jet Propulsion Laboratory that shows precisely what we would be looking at if we had a camera somewhere on the surface of Mars looking back at the Pathfinder. That's what it looks like. The airbags have all deflated. The three triangular things on the three corners of this are solar panels that are just beginning to pick up the first light of the Martian sunrise at the landing zone on the Martian surface. And what we anticipate will happen, if you look at that live picture from the Jet Propulsion Lab, it's not of Mars, it is of an identical Martian rover to the one that is on the surface of Mars right now. Right at the top, you can see a thing that looks like a little white radio antenna, which is, by the way, precisely what that white thing is. That radio antenna is communicating with the Earth already. The Deep Space Network is picking up signals from it. And about 1 hour and 7 minutes from right now, they anticipate that there will be a stream of data. They are calling it digital data, and they're saying it may not have photographic quality representations, but it will be able to tell us what the weather is like on Mars right now, coming from that antenna down here to the Earth. There's another antenna, a larger one, looks more like a satellite dish, which will try to line itself up with the Earth and then start beaming back massive amounts of data to the Earth, which would mean that by 3 hours from now, the first color photograph, a huge panoramic view of the Martian surface, would be beamed down here to the Earth. This is what happened over the past 3 hours since this thing broke through the Martian atmosphere and bounced around on its balloons on the surface of Mars. Actually, this is what's happened in the past 45 minutes. There was another big cheer at Mission Control at the Jet Propulsion Laboratory when there was confirmation that this sequence of events was taking place. Now, that particular dish antenna is looking for the sun. As soon as it finds the sun, which we think it will do any minute, it will begin beaming a stream of data, a high-speed stream of data down to Earth. Streams of data don't sound very sexy, but the pictures that go with it will be, we are told. The next thing that's going to happen today is that this little 6-wheel robot will turn on its laser beam eyeballs and its TV cameras and will begin moving out over the Martian surface. The way this thing works is when those laser beams are interrupted as they reflect back into the rover gets a message that, hey, there's something we need to worry about. And according to Donna Shirley, who is the mission manager for all of the Mars exploration missions, this thing thinks like a bug rather than a human. It has been given the artificial intelligence of a cockroach. What a cockroach would do if it went up to something like this on the floor is it would bang into it, then turn around and work its way around. That's what the rover does. What you just saw happen, the thing that looked like a coffee can coming out of the side and touching a rock, was actually taking a sample of that rock to find out what it is made of. And that's the main job of this Sojourner rover, as it is called. It goes around on the surface of Mars, looks at rocks, and tells people down here what the rocks are made of. There may be some practical application in all this. For years, people on Earth have said, we bet there's some things on Mars that could be used for fuel. Either fuel for rocket ships, fuel to keep people alive during the cold period up on Mars. And that's what the Sojourner rover will try to find out on this trip. What are those rocks made of, really? Are they things that could be broken down in a chemical analysis and things like that? So that's what's going on the surface of Mars. At the beginning of your show, Hillary, you showed some pictures of cheering people at the Jet Propulsion Laboratory. The human emotion of this is a lot neater, really, to me at this point in my day than all the nice animations and things. Let's go back to that again and just look at these people. All of them are technicians and engineers, not the kind of people who hug and kiss each other at work all the time. And just look at their reaction when all this unfolded just a few hours ago. The guy in the white shirt in the middle, one of the chief scientists on this project, been working on this for decades of his life. He is obviously ecstatic that everything is going so well. The miracle to me in all
John,
this...
I just want to jump in for a second.
Sure.
You say he's been working on this for a decade. How long? I mean, we know it's taken 7 months for Pathfinder to make it to Mars, but how long, actually, have people been working on this project?
On this particular rover, this particular idea for getting to Mars, it's been about more than 5 years. I was talking here on CNN International with one of the program scientists a few hours ago, and he said that he got the plan, minute by minute, what was going to happen on the surface of Mars 4 years ago. And they have been tinkering with that plan, fine-tuning it, making sure that they had all the equipment to do the things they wanted to do for that long a period of time. You can only launch things to Mars every 2 years, and it's a pretty narrow window. End of November, beginning of December is when you can launch things from the Earth that'll make it to Mars without using up more fuel than is possible to put in the rockets to ship them there. So they have 2 more years of work to do before the next round of satellites goes up to Mars, and they're working on them and have been for some years in the past as well.
Well, I know we'll keep coming back to you for more news on this particular mission, John. Thanks very much.
A weak signal, a modest celebration, a daunting challenge achieved. Scientists learned Pathfinder made it to Mars in one piece and should soon be sending back pictures. Hello and welcome. If there is life on Mars, it may have reason to be alarmed. Just a short time ago, a box bundled in balloons came hurtling towards the planet. It slowed from the speed of a rocket to a bullet and then slammed into the surface about as fast as a car with no brakes. And it all went according to plan. On our program today, Pathfinder and the mission to Mars. We begin with CNN's Mark Bernheimer.
It's a very good sign, everybody.
It was the moment they'd been waiting for, and it came right on time. Pathfinder landed, apparently safely, on the Martian surface.
We're sitting on the base pedal, which is the bottom of the lander, absolutely perfect position, absolutely where we wanted to be. The fact that we could hear it all the way to that point and get the signal is miraculous.
Pathfinder was the first lander designed to literally crash into the surface of Mars, cushioned by a cocoon of airbags. Assuming everything goes as planned, the rest of the mission will depend on Pathfinder's passenger, a pint-sized scientist, a coffee table on wheels called Sojourner, which will roll off the lander's blooming solar panels and begin the lonely task of exploring Mars. Through a camera and a high-tech soil analyzer, Sojourner is expected to answer crucial questions for scientists a world away.
You know, what is Mars made of at just the most basic? You know, here's this whole planet and we don't have a clue as to what it is, you know.
The Pathfinder project is not designed to look for life on Mars. Scientists already know the surface of the planet has no water, therefore no life. Any signs of life deep below the planet's surface would be well out of Sojourner's reach.
You need a dozen missions to be able to define the environments and then go to the very specific places where you could begin those very specific to answer those specific questions. Pathfinder's the wrong mission to do that.
But, say scientists, Pathfinder could be, and likely will be, the first step. Scientists know it's not quite time for celebrations just yet. At a relatively cheap price of $265 million, the Pathfinder project was built without backup systems. If anything goes wrong from this point on in, there will be no way to rectify that problem. Mark Bernheimer, CNN, Pasadena, California.
Joining us now from Pathfinder Mission Headquarters at the Jet Propulsion Laboratory in Pasadena is CNN's John Zarella. John?
Good afternoon, Jonathan. Everything here is going better than anyone could have expected. That's the real good news. Of course, the engineers here and the scientists are still, you know, things can still go wrong. There's a lot of things that have to happen yet, but so far everything looks wonderful. None of them could be happier, and here's their bumper sticker, Mars or bust, and they made it. So I guess now the key is Sojourner, the rover, getting it off the lander later this evening, and that's going to be another exciting moment. We'll be building up to that throughout the day. And of course, one of the key people, and there are many, many of them in this mission, is Matthew Golombek. And Matthew is the project scientist, and we spoke last night, and as I said to you, you were so confident. You knew something everybody else didn't know. You guys made it and it looked great.
The whole project knew it. We all knew that if you work this hard and you're committed to this with this amount, that it would work.
In that control room, give us a sense, if you can, I know it's difficult, what the emotions were as you were getting that data back from the vehicle, that it was working.
I mean, elation, but almost stunned that we got the signal all the way down. We thought it would be weak. We figured it might not even be there. We might have to wait until 2 this afternoon to actually get the first true confident signal. And we got it all. We got the whole thing all the way down. We know which pedal it wound up on. We know exactly when the airbags retracted and when it opened up. And we got the low gain antenna beep to us, implying that our telemetry system's operating.
What is the next big event coming up, and when is that going to take place?
Well, we're waiting for the Earth to get high enough in the Martian sky for that low-gain antenna to send us actual data about the internal workings of the spacecraft. Is it healthy? What are the temperatures? Are the solar panels working? Is everything ready to go? And when we get that and we ascertain its health, we then decide to unlatch certain things and start it on its job.
Matthew, Matthew, real quick, first picture.
First picture expected around 4:30 this afternoon if we get
time.
Yes, if we get the high gain antenna, which is also another big step here.
Matthew, thank you very much.
Thank you.
Talk to you again in a minute. So, a lot of things for the viewers around the world to keep close tabs to. Big events still to unfold here throughout the course of the day. Jonathan.
John Zarella in Pasadena, thanks very much. I guess that first picture will come our way in 3 hours' time. When we come back, though, more on the Pathfinder and its passenger, that curious little cart called Sojourner. Stay with us. Welcome back. In order to put Pathfinder on Mars, NASA had to design a ship that could travel faster than 7 kilometers per second on its 7-month journey. And after flying through about 500 million kilometers of space, it had to enter the Martian atmosphere in just the right way or it would burn up or bounce off. And that was only getting it there. How did they do it? Joining us now is Kurt Grimal, a professor of aerospace engineering at the University of Oklahoma. He is also the man who designed all of the animations we've been looking at today. Professor, thanks so much for being with us.
Thank you.
Let me ask you first of all about the landing site. How did they choose where to put Pathfinder, and how close did they get to actually putting it there?
Well, they were torn between 2 different types of locations. One that's exciting and mountainous and deep canyons, but that's very dangerous to land a balloon type or an airbag type lander. The other extreme is a very flat, no rocks. They lean towards going to a river delta, so it'd be flat with minimal amount of large rocks.
Now, you say a river delta. They didn't land in water, though, did they?
No, they did not. But on the surface of Mars, there is large landscapes that looks as if a river had once run through it and gouged great riverbeds onto the surface. And then it empties out into a very flat area, and this is an area that they chose.
The way they landed was very peculiar. I've never seen any kind of craft come down with such a complicated sequence. They used parachutes and rockets and airbags. Why did they have to go through that whole complex procedure?
The main reason is they did not have retro rockets to slow it down. They had to use every possible way to get it slowed down. The first thing was to use the parachute. In order to get rid of the parachute so the parachute won't fall on top of the lander, they had to have small rockets to push it away. In order the rockets will not affect the bags in any way, they had to have a tether to get it away from those rockets. And then after that gets away from it, they cut the tether and let it bounce and come to a stop by itself. You must remember, though, it was started at 7 kilometers per second or faster. And when the tether got cut, it was only going approximately 40 or 50 meters per second. So it had to slow down tremendously before it could even start bouncing.
How hard is it to land in a place like Mars? I've heard you say that there is a curse about the planet. Is it a tough place to send a craft?
For the last 21 years, all previous missions have failed, whether they didn't get out of Earth's orbit or they were lost just when they were going into the Mars orbit, and this is both United States and Russian spacecraft. So it's been kidded about a lot. that there's a ghost out there that is stealing all the spacecraft. And so it's a great day when we finally get one through after 20 years of trying.
Now, we're getting callous about it, I guess. It's an amazing thing. We get so much information from space. We get live pictures from Mir, our colleague here at CNN, Riz Khan, and callers from around the world. We're talking today live to the crew members aboard the shuttle Challenger. How much information, how quickly and how efficiently is Pathfinder going to communicate?
Comparing the Pathfinder to the space shuttle is, the distances are just enormous. It's like calling your friend across the street versus trying to call them across the country. The time distance is very great. Therefore, you need to design the mission such that you'll be able to have much of it work on its own.
I guess that really it comes down to very small amounts of information transmitted very slowly.
Think about 10 years ago, a modem was able to transmit maybe 30 bits per second. That is about how fast the low-gain antenna number 1, will transmit. The high-gain antenna will maybe get up to 2,000 bits per second, which is maybe a 5-year ago modem. We all get very frustrated on the internet with modems, and they're very, very slow. This is an extremely slow modem if you look at it that way.
Okay, we'll be getting news slowly, and a lot of people, a lot of scientists are going to be wondering about the passenger Sojourner. Can you tell us about it? How fast will it be going? How big is it? What exactly is it going to be doing out there?
It's only going to go to a distance of maybe 10 meters away from the lander during the first 7 days. This is the completion of the first phase of the rover. It will only move at approximately 1 meter per minute at the very most. It's more likely going to be moving at centimeters per minute.
How big is it?
It's kind of like a microwave oven or a small appliance, approximately 1/2 meter long, maybe 1/3 of a meter wide, and maybe 10 to 12 centimeters high.
Now, people looking at the animation that we were just showing saw what looked like laser beams coming out of the front of it. You designed the animation. Was that creative license, or is there going to be some kind of beam coming from it?
Actually, there will be beams. There's 5 of them. And they use these beams to be able to detect rocks, where they're at, and approximately how big they are, so they can decide whether to go over them or around them. And this information is fed directly into the rover. It's calculated, and then it decides whether to go around them or over them, with very minimal amount of input from any operator on Earth.
Now, Mars is a tough place to land a spacecraft. Is it an easy place to run a car? Is Sojourner going to find the conditions there friendly to it?
No, it won't. That's one of the main design criteria of this and engineering tests, is how can you travel on a sandy soil? The animation here doesn't even show how sandy it really is, but you could sink your wheels up to a couple of centimeters into that soil, and to be able to keep moving and not get stuck is rather difficult. They've had a lot of practice with the moon. It has a similar substance to it, but it's hard to engineer. You'll notice it's not a rubber wheel, it's a metal wheel, and the sand can actually go up and around the wheelbase.
Now, I'm from Canada, so I know what it's like to start a car in the winter. What are the temperatures going to be like for Sojourner?
It'll be as low as 100 degrees centigrade below zero and as hot as 40 degrees centigrade above. The higher temperature is not a big concern, it's those low temperatures. When you put batteries in low temperature, it's very hard to get the energy out of the battery. They have to keep those batteries warm so they can keep the energy coming from them.
How long are those batteries going to last? It's funny, it seems like they're sending a toy up there and just waiting for the batteries to run dry like any kid.
The mission is planned for 7 days, and the batteries will be sufficient to go through that first phase of the mission. They will hope that the solar panels will be able to recharge them and add additional power to the system to extend the mission for 2 months. That would be ideal. Then, on top of that, if it really works well, they might be able to get a whole year's service out of the rover.
Oh, we see the car. We know how it's going to be fueled. Who is going to be steering it?
It'll be a combination of its steering itself and the operators on Earth at the Jet Propulsion Lab determining where they want to go and analyze the soil. They'll basically pick out a point and then put that coordinate into the rover and tell the rover to go there. The rover will try to pick its way around the rocks or over the rocks to get to it. If it comes up to a difficult situation, doesn't know what to do, I'm sure it'll call home and ask for further instructions. But most of it will be done on board the rover.
Let me ask you a question as an engineer. How does this particular mission compare to the one that put man on the moon?
That's a difficult question. The two programs are so vastly different. One is a manned and one is an unmanned. The rules are completely different when you don't have to worry about a human being being part of the mission. On the other hand, it's a much farther distance. And the more concern is it was a very limited budget, $175 million, where the Apollo missions ran up to the tens and 20 of billions of dollars. So the cost magnitude is just vastly different. We've gotten a lot more bang for the buck out of this mission than I would say we got out of the Apollo mission.
Now, one thing that does come to mind is that Sojourner is a very simple-looking machine. It has to achieve extraordinary things, but it's not going to be doing very complicated things. Was most of the effort put into just getting it there, or are they hoping that once it's there, it's going to really achieve extraordinary results?
They're trying to do an engineering analysis of how well these rovers or future rovers will work on Mars. It's critical that they know how to get around on Mars for the next 9 missions. They have a lot of testing of this engineering that needs to be done, and that's the primary focus of this mission. They have to do it sometime, and that's what they're doing now, is testing out how to get around on Mars.
You brought us beautiful animations and extraordinary expertise. Dr. Kurt Grimal of the University of Oklahoma, thanks so much for being with us.
Thank you.
When we come back, a conversation about the next steps. After Pathfinder, there are a lot more plans for the Red Planet. Stay with us. Welcome back. Sometimes it's easy to let time pass without visiting even your closest neighbors. In Earth's case, it's been 21 years since we've sent anything over to Mars. But that's changing. Joining us now to talk more about that is Wes Huntress, Associate Administrator for Space Science at NASA. Dr. Huntress, thanks so much for being with us.
My pleasure.
An extraordinary achievement getting even this far, but this is just a first step, I take it. How much is NASA trying to find out about Mars, and how much is it planning to do to learn all that?
Well, it's really very wonderful to know that what we have is a sustained program for exploring Mars. This is not just a single mission, it's just the beginning of a set of many missions. We'll send 2 missions every 26 months when the planets are properly aligned. One an orbiter, one a lander, just as in this case, ultimately to learn lots of things about Mars. One, is it suitable for human exploration in the future? Where is the water? How much of it does it have now? What's the climate like? And how does Mars fit into the family of planets? And why is it so similar yet so different from our own planet?
Are all of the probes going to be like the one that's just landed there? Is it going to be simple machines like Sojourner on each of these trips?
They're all relatively inexpensive missions, designed with the newest of technologies and done in many innovative ways, just as this landing was done in a very innovative and very inexpensive way, and apparently quite successfully. Each of the landers will be different. We will send them to different places to learn about the different places on Mars. We'll send a series of orbiters to complete the mapping of the entire planet so that we can select the right places to send our landers. And ultimately, in 2005, we expect to launch a mission to return samples from the surface of the planet.
Now, you bring up the question of mapping. We have seen maps of Mars. School children can find them. I saw a globe of Mars. How much remains to be learned about just what the face of the planet looks like?
Well, the last time we did global mapping was with the Viking missions in '76, and they were simple cameras. What we're doing with these orbiters is to map the geochemistry, the mineralogy of the surface, the topography, the variation with height, so we know how high things are, how low things are. And we'd like to find those singular places on the planet that might be most interesting to visit it. For example, if we could find evidence of an ancient hot spring, where we know very simple life seems to abound on this planet, or places that might have rocks of the type just similar to the Allen Hills meteorite that we learned about this summer.
Well, you're mentioning visits, so let me ask you more about that. Realistically, how soon do you think it's going to be before people end up going to Mars?
Well, that's one of the reasons why we're spending so much effort at exploring this planet. Because one, we want to find out if it remains as interesting a planet as it seems to be now in terms of being a place for people to go to and holding out that carrot that life may have once started there. And we have to learn what it's like on the surface, and that's what these landed missions are for. What's the soil like? What's the atmosphere like? And can we, in fact, make fuel, oxygen, and the kinds of resources that human beings need out of local resources so we don't have to carry them there? And this could take about 10 years or more of research on the surface of Mars, at which time we'll be ready to make a decision as to whether to go or not.
When lay people think about Mars, they inevitably think about Martians. The question of life, either now or in the distant past, has come up, and some scientists think there's evidence of it. Is it possible that Sojourner or one of the vehicles like it in the foreseeable future will find more evidence that's relevant to the debate just by looking around on the dirt of the surface?
Mars Pathfinder wasn't designed to look for evidence of life. Later landers will be designed to look for the kind of chemical signatures and mineralogical signatures in these rocks that would pick them out as the kinds of samples we'd want to bring home. But what Pathfinder's Sojourner rover will do is, for the very first time, unlike the Viking lander, have mobility and go out and select rocks, look at them very close up, see if any of them have been formed by sedimentary processes during ages when Mars might have had standing water and lakes, to learn more about the history of Mars and the kind of material that might have allowed Mars in its past to have generated life, and the kind of material we'd like to go back and pick up someday.
We know a fair bit, or people like you, I should say, know a fair bit about the moon. You're now in the process of learning more about Mars. Can you just keep going on like this? Are all of the planets just waiting for people to end up sending technology or travelers to go visit? Or does Mars, for some reason, represent the last thing that we can realistically hope to discover?
Oh, by no means is Mars the last. Mars is the first. Mars has a particular place in the mind of man because it's so prominent in the night sky, and the ancients used to watch it crawl across the sky and assigned its very mysterious characteristics because of its blood red color in the sky. And in this century, the ideas of there once perhaps have been life there have certainly generated a lot of interest in it. But we're finding the solar system beyond Mars to be quite interesting in itself. For example, Europa, this ice-covered moon of Jupiter, may have an ocean underneath that frozen ice, and we're going to try to find out if that's true. And if there is an ocean there, I think that will be another interesting place we'd want to go to.
Well, hopefully we'll be talking to you again then. Dr. Wes Huntress of NASA, thanks so much for being with us.
My pleasure.
One final note before we go. If you want to see the very first pictures to come back from Mars, one of the first places you'll be able to find them is on CNN's special website on the internet, located at cnn.com/Mars. Stay tuned to CNN for the latest on the Mars mission. Coming up in a few minutes, a live report from Pathfinder headquarters with the first pieces of data from the Red Planet and the first pictures we expect in some 2.5 hours from now. That is our program, though, for this day. I'm Jonathan Mann. Thanks for joining us. The news continues in just a moment.
The following is CNN's coverage of a live event.
What a day for people who care about space exploration, particularly exploration of the red planet Mars. Let me show you what people on the ground at the Jet Propulsion Laboratory in California are able to see right now as they walk around the news press room. It's a picture, actually it's an identical rover to the Sojourner rover that is available at Mission Control out there for them to look at, planted in a sandbox. We're
just a few minutes away from the beginning.
What they're telling us there is that in about 8-9 minutes from now, we're going to get the first stream of data from From Mission Control, from the Mars Pathfinder, back here to Earth.
EDLCOM report signal detect on both subcarriers.
We've confirmed that the spacecraft is now completed pedal deployment, and we're transmitting our final semaphore on the low-gain antenna. We now expect to get a signal in the spacecraft at 2:09 Pacific Daylight Time with real digital data. Stay tuned for more excitement from Mars Pathfinder.
Well, 2:09 Pacific Daylight Time is 6 minutes, 26 seconds from right now. Out there at the Jet Propulsion Laboratory, my colleague John Zarella is standing by. John, what is this digital data going to tell people, do you think?
Well, John, the hope is that it will give them the status of all the systems and subsystems, the engineers here and all, that the vehicle is healthy, that everything is working, and that then they can proceed on with the next steps of the mission. Everything has gone just absolutely beyond anything that the engineers could have expected here. And I'm getting a nod of agreement from Donna Shirley, who is, of course, the director of Mars exploration for NASA. And Donna, you've got some, well, toys, I guess, that we've got here. The real thing is up there. And
yes, it is.
To give the folks out there an idea of where we stand right now on Mars, what is the situation?
Okay, the situation is, if we can focus in on this toy, this is the lander. Now, this doesn't have the airbags on it, so the real lander has these airbags sticking out. When we landed on Mars, we actually came in and landed and bounced and rolled and tumbled and came to rest on the bottom of the spacecraft, which
couldn't have been better.
Couldn't have been better. Absolutely perfect. See, we could have, even if we landed on the side, still opened up to the bottom, but we didn't. We landed on the bottom. Then we got a signal that the airbags had been fully retracted. That is, the airbags had little strings inside them and a little fishing reel that reels them in and pulls them up tight up against these, up against the pedals. In fact, here's a piece of airbag material. So you can picture it there. Then the pedals opened up like this, and we know that it's opened up, and we know that the rover is sitting on one of the pedals like that, and the next thing we're going to hear is the data that says, okay, we made it down, here's everything that happened to us on the way down, and that all the subsystems and the rover are healthy.
All right, what we're going to do is throw it back to Atlanta, to John Holloman, and try and get take a break here for a minute so that we can get back when all of this exciting information hopefully starts to flow back down to Earth.
Good.
John, back to you.
All right, Donna Shirley, John Zarella, thank you both. We'll take a quick break. We'll be right back, and perhaps when we come back, we'll know things about things going on Mars that we've never known before. Stay with us. Here's what's coming up. First pictures from Mars, 7:30, about 2.5 hours from now. First weather report at 9 o'clock Eastern Time. Color horizon picture, the big picture, coming up at 9:30 p.m. Eastern Time. Quickly, back to the Jet Propulsion Lab, where John Zarella and Donna Shirley are waiting for the first data from Mars, which should begin arriving in 52 seconds. John,
you know, and one of the interesting things, too, about Mars, this first sunset may be blue instead of red. They said there's some possibility.
That's what Peter said.
Yeah, Donna Shirley is with us. And just to give our viewers an idea of just how small everything is, tell us what that is.
Okay, this is a stretched-out radio. And this is a commercial radio modem built by Motorola that we have qualified to go to Mars. And when folded up, this thing is the size of a cigarette pack. And we have one of these on the rover, and we have one on the lander, and that's how the lander and the rover talk to each other. They're not actually connected at all.
And this is one of the ways you're able to do these missions faster, cheaper, better.
Right.
Everything has gotten so small and compact.
Right, and we're being able to take advantage of commercial technology is also very important.
So, John, you can see that we've got our little micro circuit here. We've got our rover, and now it looks as if all we've got to do is wait here for the signals to come back from Mars to let us know that all of these things are working and working properly. And then you can move on to the next step, correct?
Right, that's right.
And what will that be? Then what do you do?
The next step is that the lander camera is going to locate the sun, And then the high-gain antenna here will swing up and point to the Earth, and then we'll be able to send back a lot of data so that we can actually see pictures.
Mission control right now. I think we can hear what's going on there.
Can we?
Are they still waiting, Donna? Can you tell?
Oh, here we go. Are they talking?
They're not saying much, Donna. John, I'm looking in on mission control while you were talking with our viewers.
Okay.
But everybody's pulling out their home movie camera and their home still camera. A lot of, it looks like high school reunion time, actually, in mission control.
Of course, it's a 10-minute delay, right, in time, and these things are not precise.
No, these are Earth receive times.
Earth receive times.
It is not precise.
I'm looking at a computer screen in mission control right now, and it looks like there are some streams of old data on it, and people are beginning to gather at a couple of these screens, hoping that they're going to see some new data when it comes in. There's one man in there who is making a home movie of the computer screen, so when that first data begins to come down on the screen, he will have it for his grandchildren.
Okay, well, why don't I talk about what's going to happen?
And when you get it, it doesn't necessarily mean for the viewers out there that there's anything wrong because we're not hearing anything right now.
Absolutely not. In fact, we don't know exactly when anything is going to happen. The 209 was the earliest time when we would expect the data back. And it could be that, you know, because of conditions around the spacecraft. For example, if the spacecraft landed where there's a big hill next to it, we have to wait for the Earth to get up above that hill before we'd be able to hear it. So it might be as long as, you know, 30 minutes to an hour before we actually get it back. This was just if everything was nice and flat.
And, and then what happens?
Then it will send back a signal saying, okay, here's what happened to me on the way in. Here's all the bumps and lumps and the parachute being deployed, and all those events will be captured, plus all the health of the systems, including the health of the rover and the health of the lander electronics, because the rover will send its data, says, here's how healthy I am, to the lander, and then the lander, over this low-gain antenna, this little stalk here, is going to be sending that back to Earth at a low data rate. So this is our first downlink, and it really depends on when the Earth gets up above the horizon.
Now, I understand I was talking to some folks about the airbags, for example. You'll even be able to tell how far you bounced, how high you bounced.
Right.
That's amazing.
Yes, well, there's accelerometers in here, and every time you bounce, there's a hit on the accelerometer. And so once we know how many bounces, and we know how far apart they were, and we know where we ended up, then we'll be able to tell how far we actually went.
Donna, do we know anything about the atmosphere on Mars? I mean, what it is made up of, and will we know more after this data comes back from Pathfinder?
Well, we know that the atmosphere is almost entirely carbon dioxide, and that it's approximately 1% as dense as the Earth's atmosphere. Viking told us all that very well, and we won't add to that. However, what we will add is what it was like coming in, because we only have 2 holes in the atmosphere that have ever been bored before, and that was by the 2 Viking landers. So this is a 3rd hole that's being bored in the atmosphere, and we'll be able to compare the things that happened on the way down. Will tell us how thick the atmosphere was at different parts of it, and maybe which way the wind was blowing and what the temperatures were. We really get a lot of information about the profile of the atmosphere as we came through it.
Does that
information?
Go ahead, John. Excuse me.
No, I was just going to say, John, I think that information is really going to be critical, isn't it, to future missions?
Yes, it is. It's especially critical to our future landers, but it's also important for Mars Global Surveyor. Mars Global Surveyor is going to go into orbit in September, and instead of going right into the low mapping orbit, the low polar mapping orbit that we want to be in for our 2-year mapping mission, our 2 Earth-year mapping mission, we'll end up in a big, loose orbit.
That we have symbol sync and we're waiting to get frame sync. We expect that to happen in 5 to 7 minutes.
Frame sync in 5 to 7 minutes.
Which means?
Which means that that's when we'll start to get the data.
Digital data.
When we do frame sync, we'll have digital data. What that means is the data is coming into the Deep Space Network, and it's kind of going beep, 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 beep in little bits.
So it is coming in now. Now they know it's coming in.
They know it's coming in, but they don't know what the content is. Then it has to synchronize up so that the data comes in little packets of information, and those packets have to be synchronized so that it reads the right time to start and the right time to finish, and that's called frame syncing. And so that has to happen before we can understand what the data tells us.
But that's another good sign, isn't it, that the information is, they're getting it?
Yeah, the bits are starting evidently to come in, and it's just a matter of synchronizing the radio on the ground
so that the information is being received properly.
Well, we've got some time now to wait, another 5 to 6 minutes, and we're going to take a break from here. It's a lot hotter here, isn't it, than
Yes,
it is on Mars?
Yes, it is.
It's certainly not like this there right now.
No,
It's probably a little chilly.
On Mars, it's about 100 degrees below zero right now.
I'm not sure which is worse about this particular point in time. But, John, we're going to throw it back to you right now and take a break here at the Jet Propulsion Laboratory.
That red planet behind me is becoming more and more clear to people on the ground. We're going to go back into the Jet Propulsion Laboratory where, Donna Shirley, I'm told we have a frame of data. What does that mean, and what do you think it indicates, and what is it going to tell us, a frame of data?
Well, a frame of data is one piece of information that describes, in this case, the condition of the spacecraft. So this is really exciting. This is the data we've been waiting for. This is the Mom, I made it, you know, the safe arrival phone call. Yep. And this is what we've been hoping for. Yeah, and I can see Dan Golden, the administrator of NASA, Ed Stone, the head of the Jet Propulsion Lab there with some of your scientists, your team leaders. I don't know if you can see them on TV or not, but they are looking at that computer screen with great interest. And I know Dr. Stone is a man who has a lot of experience with computers, and Mr. Golden's a man who used to design spy satellites. So this kind of a day for the two of them, with all of their knowledge from their backgrounds, must be scintillating and exciting. And nobody's frowning. That's a good sign, I think. That's a good sign. I haven't heard a lot of screaming yet, though, so that's my indicator, since I'm out here on the mall instead of being in the control room.
One frame is not much, right?
One frame's not much, but if we got one frame, we got a bunch of frames.
How many frames is it going to take before you have a good feel? I mean,
you would ask me that,
wouldn't you? I would
ask you
that.
Yes.
I'm sorry.
I don't know the answer to that.
A lot of frames.
Yeah, a lot of frames. Well, a frame is, John just described it beautifully a while ago. It's like email. And when you send email, it goes in chunks, you know, like it'll show up, like when you're printing a picture out from the internet or some data out from the internet, you know, you get a piece of it, and then you get another piece of it, and another piece that shows up on your screen. Well, this is that same kind of thing. And it has to be synchronized so that the receiver and the sender are going along at the same frequency. And that's what syncing is.
I was just asking you a very non-technical question.
And I made it technical.
No, not that question. A question before. Would you have ever imagined the level of attention that this mission has got?
Well, actually, yes. I was the one that predicted 4 years ago that we would have this kind of attention, and nobody believed me. So I'm happy to be vindicated in this case. Now, what I just hope is that everything keeps going as well as it has gone in the past. So I'm waiting for the rest of those frames to come in.
There's still a lot. Go ahead, John.
Let's go back into the control room. Tell us who the people are in that picture. They are big. I see Ed Stone in the middle, the JPL director. You're a ship controller.
I can't.
There's a glare on our.
There's a glare on our screen.
Hard for us to see who exactly is in there. It looks like Jennifer Harris there is the one of the.
Yeah, it could be.
Jennifer Harris on the left, one of the flight controllers.
Okay. Yeah. Brilliant red hair. Yeah.
That's Richard Cook on the far right. Brian Muirhead with the bald head next to Ed Stone.
We have the
All right, they got it. They got it. Woo! Woo!
Another great moment.
Another great moment. All right, there are so many great moments here. I don't know what they got, but they got it.
They got something.
Donna, don't have a heart attack.
I'm not having a heart attack. I'm happy.
There are cheers all around. Maybe we can listen in to the mission control and see what it is they've got.
Good plan.
Yeah, no children.
How's the day looking? Oh, broadcast 6 minutes.
Yeah, the computer screens in Mission Control are filling up with data. I can see it on the wide picture we have of Mission Control right now.
Flight software.
Go ahead.
Preliminary, no EBR warnings as of the first packet down.
Good. Keep in mind that packet time was 2052, just before S12 started.
That means everything's okay.
John, you might have heard just now, that was Donna saying that no warnings means that everything is okay in the first packet of information.
That's right.
And a packet of information is
some amount of bits that makes some numbers that tell us the condition of the spacecraft.
Of certain systems. Any particular systems that were coming first, the information first, or you have no idea?
I have no idea what order.
Do we have command mode on at this time? Yes, we do. Thank you.
Donna, that's real good news. Now, this the computer inside the Pathfinder is designed to send you warnings if it detects anything wrong. It's kind of like your home computer. If you've lost a program or something, a little message will come up, and that's sort of what these packets of information are. Am I right?
So everything's pretty clean right now. Now the content, the controllers actually have to look at the data for a while to see if everything's within limits. Now they do have alarms that are set up so if something's out of limits, it would say, whoops, I'm too hot, or I'm too cold, or I've been stressed too much. And so far I don't think we have any of that.
It's kind of like when you get a big
This is Mars
blood
Pathfinder
workup.
Mission Control at the Jet Propulsion Laboratory.
Flight, can you give us an update as to when we expect to see DPT-9 active, which means we get data other than
I believe we're going to get 3 more EH&A packets before we open up DPT-9, which then would start allowing the EDL data.
Okay, I can't
understand what they were.
This is Mars Pathfinder Mission Control at the Jet Propulsion Laboratory. Obvious exuberance in the flight control team when the data started to come in. Not only data, but they were not only the carrier signal, but they were actually receiving data. Now the team's back to business as they start to analyze that data and interpret exactly what the state of the lander is. Jennifer Harris, the flight director, in the center, and Richard Cook to the right.
They'll be telling you what the data is at the press conference, which I think is coming up at 2:30. And so right now we have to just kind of wait for them to look at the numbers on the screen, interpret those numbers, understand which
There's going to be a project statement coming up in just a few minutes from Brian Muirhead, Deputy Project Manager and Flight System Manager. This is Mars Pathfinder Mission Control.
Here comes Brian, as a matter of fact, with Dan Golden and Ed Stone. So
I wonder if we can get Dan Golden to come over here for a...
Well, Brian's more important.
Brian and Dan Golden. We've got to try and get them both over on CNN very quickly.
I'll talk while you go grab them,
the administrator. We know. We're on live right now, Mr. Administrator. 2 seconds with John Holloman. You got 2 seconds? Just 2 seconds. Very quickly. Very quickly. John Zarella, Donna Shirley, and John Holloman in Atlanta. This has got to be a tremendously... Well, I'll get out of the kiss. Grab this and talk to John. John, you have a question for the administrator? And maybe Mr. Administrator, a comment.
His reaction when those first frames of information came in.
Your reaction.
Oh, this is wonderful. I was just over in the control room, and we had a grand total of 15 people, John, that were operating this spacecraft. And in the past, we had hundreds. And it landed, and when that digital signal came through, the sky opened up, and it was nice and clear, and the sun was shining.
And you proved that cheaper, faster, better works.
Well, we're not there yet. I want to be very level throughout this, and I also have to leave because I have to speak to the Vice President.
Thanks, Dan.
Thank you very much, Mr. Golden. Appreciate it. Well, that was good. I'll throw my mic back on here now, John.
Little target of opportunity.
Yeah, target of opportunity. We never seize an opportunity at CNN.
That's right, that's right.
Anyway, John, so he's on his way over. So that news conference ought to be starting in about, about 4 or 5 minutes,
yeah,
Donna?
Looks like it.
They should have some indication then of what the data is.
Right, right.
And how good it is.
Yes, I think it's going to be good. But I hope they've had time to at least look at it a little bit, because Brian left up there while they were still looking at the numbers. So,
well, that must be a good sign, too. He doesn't seem like that's the deputy project manager, right?
The deputy project manager.
He seems to be pretty comfortable with what's going on.
Yeah. I think we're okay. I mean, at least so far it looks like we're okay.
How long will it take them? How much data will come in? How long will this downlink of data be going on?
Well, this downlink of data goes on now. They'll be downlinking data the rest of the day until Earth sets. And Earth sets, I think, around 8:30 or 9 at night, tonight, something like that. And so we'll be getting a continuous stream of data. The next thing we're going to do is to see if the high-gain antenna is pointed in the right direction. And then we can start to get back data at about 2,500 bits per second.
So you can do this simultaneously then. You'll be getting low-gain data all constantly.
Well, no, I think we stop doing low-gain, and if we can get it onto the high-gain, then we send it over the high-gain. Now, the data that comes in from the low-gain is about 250 bits per second. And if you have a really kind of funky modem on your computer, it's at least 9,600 bits per second. So the low-gain is very slow. But even the high-gain is only 2,500 bits per second. So it's only about a quarter as fast as a really bad, not too good modem.
It's the one I'm working with in the computer back in the trailer right now. It's exactly what I'm working, 9,600.
So it takes a long time to downlink a picture. As you know, when you try to downlink something from the internet, how long that takes. and so it takes even longer from Mars. And then we send them over to the image processing lab, and I was just talking to Bill Green, who is our image processing laboratory leader, and he said it'll only take them a few minutes to process the pictures once they get them back. And Peter Smith, the principal investigator for the camera, will be standing right there looking at the screen, and if the calibration is right and the colors look right and it looks like it's a good picture, then they'll send it right out and it'll be in the press conference, which is maybe they'll be, not the first picture. The first picture will be there at about 4:30.
But the world will see the pictures very quickly after you see them.
That's right. We put them right out on NASA Select. You guys can put them out to the world. That's why you're here.
We certainly will. We certainly will.
And they'll also go on the internet.
All right, well, John, we're going to go back to you now so that we can get ready for that news conference in just a couple minutes. John?
That's some good questions, old friend. All right, we got a few times to tell you about. 2 hours from now, first picture. Maybe a little bit sooner, we don't know yet. 9 o'clock Eastern Time, first weather report. 9:30 p.m., first color wide-angle picture of the horizon on Mars. And what we have been seeing just time after time after time, we saw just a few minutes ago as the first positive data came back from the Mars Pathfinder saying that everything on board was okay. Let's listen and look at the reaction there in the Mars Pathfinder mission control room one more time.
We have
All right. That's it for our coverage from right now. Our journey to the Red Planet. A lot more to do tonight. We'll take a quick break. We'll see you very shortly. John Holliman, CNN reporting.
The following is CNN's coverage of a live event.
What a 4th of July they're having at the Jet Propulsion Laboratory and all around the United States, where people who are interested in the exploration of the solar system around Earth's sun are seeing the first live data being beamed back from the surface of planet Mars that's happened in about 20 years. A news conference is about to start at the Jet Propulsion Laboratory. Dan Golden, the administrator of NASA, just stopped by CNN's John Zarella's live position to let us know that the Vice President of the United States is out in California. Mr. Golden and the Vice President, as you'll probably remember, were live with us here on CNN yesterday afternoon at about this time. They'll be holding this news conference along with the mission and planetary scientists at the Jet Propulsion Lab, who have just gotten word that the Pathfinder space probe has every system that has been checked and has had information beamed back to the Earth is working just fine. John Zarella, before this news conference gets underway, you have been assimilating information for a long, long time today, yesterday, and in the previous days. There's nothing really going wrong here, is there?
No, and that's certainly a surprise to everyone. They had contingency plans lined out that if this went wrong, they would do this. They'd move to this contingency plan. And so far, none of that has happened. It has gone swimmingly, much better than, as well as anyone could have hoped. And the hope now, of course, is that it continues to move along in that direction, going as well as it has. In the course of events, something could go haywire at this point and from this point on. But so far, that's not the case. And, you know, I guess, Don, one of the things, we can't call this a spacecraft anymore, can we? It's a lander.
It's a lander.
I mean, it's on the ground. It's not a spacecraft.
Yeah, it's a lander and a rover. It's 2 spacecraft now.
It's 2 spacecraft.
It's thrown away some of its previous incarnations as a spacecraft, and now it's a lander.
All of those work perfectly. Nothing went wrong that you know of at this point. And now you move on to getting the lander, to getting Sojourner off.
Right. Well, the first thing we want to get back is we want to get the camera to look around and take a picture. And what the camera will do will point at the rover's pedals and then point around to see if any of the airbags have lopped over onto the pedals. Now, here's some airbag material. What we don't want is for it to look like that. We want all these airbags to be neatly tucked underneath. And once the airbags are tucked underneath, and especially around the rover pedal, then we know it'll be okay to stand the rover up, to deploy the meteorology mast, which is over on this pedal, and then to unroll the ramps. And then the high-gain antenna will be sending back some data. And if we get a good picture, then we'll know it's safe to send the rover off.
And these are solar panels, which is another reason why you don't want any of this material over the top of it, right?
That's right. All the power comes out of these
right
pedals.
out of these pedals. That's the solar panels.
And we need to get the rover off because you can see the rover's sitting on top of some solar arrays.
Some of the solar
so
arrays.
It's actually blocking the solar energy. So not only do we want to get the rover off so she can go to work, but we want to get her off so she's not blocking the solar arrays.
Hey, Donna, it's John Holloman just jumping in for a minute. If everything goes just the way you want to, how many different pictures of Mars will we have? I can't finish the question. The news conference is underway. We're going to go there. I'll ask you when we get done.
Our first telemetry from the spacecraft. This is way beyond our expectations. The whole day has just been extraordinary. I don't think any of us expected today to go like it has. Every time we looked for the spacecraft, it was there. It gave us clear indications it was on the surface, that it was healthy within 3 minutes after landing. And now, just now, we received our first telemetry from the spacecraft. We're getting down the health of the spacecraft, and it sounds like everything is absolutely perfect. So we hope to be able to continue the day with images coming up soon, and then maybe even the rover. So I can't be any more excited than I am, and I know the whole team feels the same way. I suspect you guys share in this with us as well. Thank you very much for your support.
Mr. Golden.
What a birthday today. There's a lot of fireworks in the mission control room where I had the privilege of talking to some of the people who did this. And it's interesting. This is a revolution just of the type of the revolution that formed our country on the day of our birthday. The people who formed our country weren't afraid of taking risk. They weren't afraid of doing things differently, just like the Mars Pathfinder team. And they're doing just a terrific job. And you could sense the pride among each of them as they hugged each other. There's a tremendous warmth. It's just not respect, but it's a warmth. And I think this is going to change the history of the space program. Congratulations, Brian. And to you, Tony Spear, who's listening right now.
Dr. Stone.
Well, what a way to celebrate the 4th of July. Doing what no one has done before. That's what NASA's all about. That's what JPL is all about. And I think today, the Pathfinder did what no one has done before. And of course, they have a number of days ahead now of doing things that nobody has done before because nobody could do them before. So it's, again, congratulations to the team that made it all happen. It really has kicked off a new era of Mars exploration, which is going to be a very exciting period for everyone.
Now we'll start with Q&As. Seth? Do we have a microphone? Just go.
Seth Borenstein, Orlando Sentinel. Do you know where on Mars you are, how close you are to good rocks or stuff yet?
No, we don't. And we won't know that until we see our first images down as far as what the terrain looks like. But we know we're down, we know we're very healthy.
Do you think you're in that last circle from before? Or?
Well within that. And we won't know until we've spent some more time with the ranging.
The phone is ringing here.
I think we might have a phone call.
Hello?
Guys, just stand by.
Could be E.T.
Hang on, if y'all stand by for a minute.
I'll hang up, they'll call back.
Probably.
You guys want to distribute the late
The phone call is going to come from the Vice President of the United States.
Mr. Vice President?
We'll listen in.
Hey, Dan. Congratulations to all of you out there on behalf of President Clinton and
all of the people of our country, happy 4th of July, and congratulations on doing an absolutely outstanding job.
Well, I tell you, I'm here with the Deputy Project Manager and Ed Stone, the Director of the Jet Propulsion Lab, and I can't begin to tell you what a wonderful job these people have done for our country.
Well, congratulations, Dr. Stone and Brian Muirhead, and to all of the members of the team who've been a part of this magnificent accomplishment. The whole country is just very proud of what you all are doing and have done today, and what a great way to celebrate America's birthday and celebrate our country's know-how and ingenuity as we press forward to new heights and new frontiers. I'm very excited about this. I've been following this throughout the day and watched the cheering there when the signals came in when you were going down through the atmosphere, and like everybody else, I'm looking forward to seeing the images when they come through. And I know that not too long after you get the first images, you're going to be deploying the rover. And I had a chance, Dan, when you and I were out there, when I made the announcement on the new X-33 on behalf of the President, we got to see that model or that backup firsthand and how it works. And it's just amazing that so much technology has been able to, you've been able to put so much technology into such a small vehicle. It's really just a very exciting and historic moment. And I do want to congratulate all of you. And Dan, to all of NASA, this new way of doing business, faster, better, cheaper, is certainly being borne out by this dramatic success today. And keep up the good work. The President and I are both very, very proud of your accomplishments, and the entire country is just reveling in your success, and we all congratulate you.
Mr. Vice President, we couldn't have done it without the tremendous support you and the President have given us. You've been there at every step. You knew it was risky, but you trusted us, and we wanted to come through for you.
Well, you sure did, and I'll be watching very carefully, along with the many millions of others, as the images begin to come through, and as we follow the adventures of this vehicle going out onto the Martian soil. So we're all going to be watching carefully. Good luck, and congratulations again.
Thank you very much.
Thank you.
Thank you.
Bye-bye.
We have some more data coming back, I understand, so I think Brian probably has to leave, and we'll be back again at 3:30 for a more formal, extensive press conference. Thank you.
So, the more formal, extensive press conference without the staged phone call from the Vice President will be coming up in, well, just a couple of hours from now. And when it happens, we will be back with more live coverage. And there are some other things going on in the world we want to tell you about, too. That will be coming up as well. Stay with CNN.
The news of the day, a world view from CNN.
I'm Hillary Balker in London. Mission Control erupts with emotion after Pathfinder sends a long-distance thumbs up. We'll have the very latest on the U.S. Mars mission.
Thank you for joining us. For the first time in more than 20 years, a spacecraft from Earth has traveled for 310 million miles to land safely on the planet Mars. You can imagine how excited the scientists at the United States Space Agency, which launched the craft, were when they learned the good news. To tell us about that and the rest of the good news that keeps on coming, we turn to CNN's national correspondent, John Hallman. Hi, John.
Hi, Judy. I got to tell you, they just keep yelling and jumping up and down and hugging each other at the Jet Propulsion Laboratory's Mission Control, because everything that is coming back from Mars seems to be great news. For the past 45 minutes, the Mars Pathfinder has been sending back data to computers on the ground at the Jet Propulsion Lab. That data has been fed into another computer that can generate a picture from the data of what is happening on the surface of Mars. And this is what the picture shows. This is how the Pathfinder descended through the Martian atmosphere and came down onto the surface of Mars. And there is a picture of what it looks like right now. Rather than having to go through contortions to end up in precisely the proper configuration, it landed with its bottom on the surface of Mars rather than one of those panels on the side. And now this Pathfinder is all laid out on the surface, ready to begin the next part of its job, which is the exploration of this red planet that is, if not Earth's nearest neighbor, the other planet close to Earth that is most like our own planet. It is happening right now. The scientists and engineers, as we say, have gone through these very joyful, jubilant moments time and time again. Here's the last one, when that data, which you just saw transmitted into a computer animation, was received in the JPL's mission control.
We have
Moments later, the administrator of NASA, Daniel Golden, stopped by CNN's live position there to tell us that this was not 100% vindication for his cheaper, faster, better policy of sending things that don't cost a lot of money out into space. But he said the news so far certainly was good, and he talked about the 4th of July, American Independence Day, as he spoke to a group of reporters at a news conference just after he stopped by our live position.
What a birthday today. There's a lot of fireworks in the mission control room where I had the privilege of talking to some of the people who did this. And it's interesting. This is a revolution just of the type of the revolution that formed our country on the day of our birthday. The people who formed our country weren't afraid of taking risk. They weren't afraid of doing things differently, just like the Mars Pathfinder team. And they're doing just a terrific job.
The three of the leaders of the space program that resulted in this return to the red planet were sitting there to take questions from reporters when all of a sudden the telephone rang. And guess who was on the other end of that phone line, Judy? The Vice President of the United States, who is also chairman of the President's National Space Council.
Congratulations to all of you out there on behalf of President Clinton and all of the people of our country. Happy 4th of July, and congratulations on doing an absolutely outstanding job.
So, right now what is going on is that more information, more data is being received at the Jet Propulsion Laboratory, where my partner, John Zarella, is standing by. John, have you heard anything more recent than what we have gotten in the past 15 or 20 minutes?
Well, we've got a little more information. I know you're big into computers, and I want to tell you that their website Meister was just by here a few minutes ago, and he was telling us they already had, just today alone, 8 million hits, and that's just right here on at their website right here. So that's a tremendous indication of the volume of interest out there in what is happening on the red planet. And what we did find out, and Donna Shirley is here with us to continue discussing this. I heard you had some more good news. Tell us about landing the 2-degree angle. What does that mean?
Right. Well, Brian Muirhead stopped by on his way back from the news conference. The deputy project manager, and told us that the lander was tilted at only 2.5 degrees, which means it's flat as a pancake. So it's just perfect. And if the airbags have been pulled in properly, there should be absolutely no problem getting the rover off.
So there's a good indication now. I know I overheard Brian talking to you and saying, we're going to get that rover off today. So
that's
things are really moving along well.
They're just incredible. Now, we just got the data back. The engineers still have to analyze it to make sure that everything's okay and understand the state of the spacecraft, but apparently everything is alive and well. We won't know exactly how much, everything is until some of the data has been analyzed, and I think the next press briefing they'll bring that information forward.
And that should be in about 20 minutes, 30 minutes or so.
Right. And I wanted to mention that this website that got the 8 million hits is just one of about 15 sites that we have worldwide. I mean, everybody is mirroring for us. So if you can't get into the Pathfinder site, go to one of the mirror sites and you should be able to get in easily.
Obviously, tremendous amount of interest is still building as we move on towards the first picture. Everybody out there wants to know, first picture, what are we looking at now? When?
Well, that first picture is coming back around 4:30, and maybe by the end of the next press briefing, we'll have a picture. That picture is not going to be anything you'd want to write home about. It's just a little picture, just a very highly compressed picture, just to look at whether the airbags are safely tucked in or not.
That'll be that first image that we'll get. That's about 7:30 Eastern time, and if all that looks good, then they'll proceed on, NASA, to the engineers here, to moving to the next step, which would be getting the rover off the vehicle sometime this evening. So, John, a lot of exciting things yet to come here from the Jet Propulsion Laboratory. John?
No kidding. You guys try to maintain your energy levels and not fall over out there. We'll be getting back with you throughout the night. Joining us here at CNN Center is Professor Kurt Grimal, formerly of Georgia Tech. While he was there, he came up with all the terrific video animation that we were able to show you before the Mars Pathfinder landed on the Martian surface. Doctor, how are you feeling at this moment?
Oh, it's just wonderful to see everything that has been planned come to fruition. 100% successful so far. They only have about maybe 40% more to do today to have 100% completion for the day.
Yeah, now this rover, you've got a model here that it shows pretty much what's going to happen. The fact that the Pathfinder is not tilted, it's just about, as Donna Shirley said, flat as a pancake, means the rover is going to be able to start its work pretty easily, correct?
That flatness means two important things. First of all, that the sunlight, when it does come up, will be hitting this evenly, so they'll be able to get power on these solar panels. The second one is that if it's flat, it'll be able to roll off very easily.
Yeah. Now, how far can the rover go?
They're going to plan for the first 7 days to be able to go up to 10 meters away from the lander area. The next 2 months, they'll try to go out even further. And if they're lucky and have everything work properly for the 2 months, they'll try to go for 1 year, in which they'll go out even further.
Wow. So they could, they can't plot. I mean, on the surface of Mars, this is a Martian globe that you have brought in. Show us in general where the landing zone is and where, I mean, how much of that could the rover cover, given that it's in reality, it's only about this long, and the wheels are fairly small, and even if they were spinning fast, it couldn't get very far.
Well, for the audience at home trying to locate it on their own Mars globe, I'm sure everybody has one. If you find the large canyon area, it is to the right and a little further up in an area right here. Now, the area in which this rover is going to go is so small, my finger would cover the whole area. It's hard to show it. Even a pinpoint is about all the area it's going to cover by this rover. But what this technology is going to show is that they can move a rover around the surface of Mars, and hopefully on the 3rd and 4th, maybe 5th mission back to Mars, that'll be happening in 4 to 5 years, that they'll be able to even go kilometers away, maybe even 100 kilometers away.
Kurt, our viewers are asking, how big is Mars compared to Earth? If you put them side by side, Earth would be about twice as big.
That is correct.
And if you were going to look in the night sky tonight and try to find Mars, which way would you look? That may be it. That's a question you were not prepared for, but what can you tell?
I'm going to have to plead innocence on that one. I'm an aerospace engineer and not a planetary scientist.
All right, I'm gonna find out. And next time we come back, I'll tell you which way to look from wherever you are in the United States or around the world to pick up the red planet. One thing about it, during the days of the Hale-Bopp comet, when my 4-year-old and I went outside and pointed our binoculars up, long before we saw the comet, we saw the bright red planet. It is not hard to spot. It's the reddest big thing in the sky anytime you point your binoculars or telescope up that way. Judy?
All right, John, we're going to hold you to that promise and ask you to tell us exactly where Mars is in the heavens the next time we talk to you.
It's a deal.
Thank you, John Holloman. NASA will hold its next news briefing a little later in our program. CNN will bring you that news conference live at 6:30 p.m. Eastern, 3:30 Pacific.